This conference will now be recorded.
So hello everyone, welcome to our 25th class in our or day in our Google Cloud Architect training. So last week we finished looking into the small demonstration or a walkover of how dedicated interconnect looks like. A very important piece where if it's a very big organization where you can have a VLAN, a virtual LAN between your data center and Google data center so that the communication between these two network is going to be using a very high speed bandwidth, something like minimum 10 Gbps to maximum 200 Gbps is what we saw. Uh, One important thing to remember is because because it is between your data center and Google's data center, the connection is not encrypted, folks. It's already a private connection. You're not communicating over internet from your data center to the Google's co-location facility. So you're not doing over public internet. They usually it is not encrypted. The connection is not encrypted. It's already private. If it's already a private, people don't do encryption. So, but if you still need to do something, you can use some other kind of an encryption apart from cloud VPN. So you can do that. So, but it's usually not expected to have a encryption between your on-prem and your co-location facility because it's a private connection. So that is what we had seen. So this works only if you're very close to one of the co-location facility. So for India, if you are in Chennai, Delhi, Mumbai, this is going to work. But if you are in, say, for example, your data center is in Noida, is it in Bangalore, Hyderabad, then or any parts of the in India, you will not be able to leverage dedicated interconnect. The one which you have to use is basically, if I go to my hybrid connectivity, so last week towards the end we saw this demonstration, so it's good that I reiterate it once. So if I go with dedicated interconnect, it's between my on-prem directly to the GCP network, and there is two connections. So one is a redundant connection for high availability, so you can get up to 4 nines of SLA. So that's the reason you have two connections always. So if I go, I need to order a new connection. So by default, if you don't do anything also, right, it's going to be $3,400. So one is the main connection, the other one is a redundancy. For so if you don't want redundancy, you will not have that SLA of 49. So only 1,700 is what you can pay, but there's no redundancy. So the location matters a lot. So it matters a lot. So we have only in Delhi. Delhi we have when it comes to India, or uh, Mumbai, or Chennai. In India, these are the only things which we get. Now, if I try for something like, so I don't get it. I don't get it. Uh, or if I try something with Bengaluru, so or Bangalore, so you will not get it. So because there's nothing of that sort exist. So basically, it is only in these three places you can select it. And I usually prefer to use, if I say, for example, if I select Delhi, I'll select one link from Tata Communications Delhi and other one from CFI Red Fort Noida. So this is how I usually select, so that we plan to have a redundancy even in the co-location facility. What if that location itself goes down due to some kind of a calamity? So that's going to be always a good choice. And sometimes people also go to some extreme. They create a redundancy, like what if the entire dedicated interconnect, yes, they provide 4 nines of SLA, what if both the co-location facilities goes down, but you still need to establish a connectivity between your on-prem and GCP. What would be the option which you can prefer there, folks? Assume both this co-location facility goes, both are very close in Delhi only, Delhi or close to nearby Delhi, like Noida. Uh, if this goes off, what could be your plan C? Plan A is the first link. Plan B is the second one. Plan C, what would be the plan C, folks? If dedicated interconnect fails, what's the backup for it? Any thoughts? Between your on-prem and GCP, you need to have a connectivity established. Things needs to continue working. What could be the option which you can think of? On-prem to GCP, two different networks. One is GCP, other one is a non-GCP network. What could be your alternative? I got this question, something on the same lines in my recertification. Yes, Anil B, that's the right one. Anybody else? Oh, you put it in the everyone. So please put it as this thing so that everybody will think. So cloud VPN could be a plan C, folks. It could be a plan C. So let me put this in the examination cheat sheet. Uh, so so prefer to have a redundant network or redundant connection in dedicated interconnect uh, to have 4 nines of SLA. Use cloud VPN as as an alternative or as a backup for on-prem to GCP connectivity. Something on the similar lines I had got it. So cloud VPN still can be a good choice, but you may not expect that level of bandwidth. But since instead of not having a network connectivity itself, you have a connectivity which is like about uh, about say for example 3 Gbps, 3 Gbps. So that's what you get. You select something like 1, and you can see up to 10, 20, up to multiples of 10 goes up to 80. Each is one link, uh, uh, and you can also have 200 Gbps. Uh, that is also possible. So you select it. The price is going to be very expensive, and give a name. Okay, IC1, interconnect 1, then interconnect the redundant one. So you choose this, it's your choice. If you don't choose this, you're going to get this warning message that it's not going to be covered as part of your SLA. So better to have it, better to have it. And I will not choose Tata Communications, but I'll choose the other one, which is going to be CFI. So now we cannot do further demos, so because you have to enter the company details, all those things, and there's going to be a letter of authority, LOA, will be sent. Some more details would be sent. Better to put always the network engineer, the on-premise network engineer, or the head of the network engineer details here, because they can interact with Google team very easily because they work on the networking part. Rather than putting a cloud architect's email ID, it's going to be better to put the involve the networking team to do that. Okay, this is the option if you are go close to one of the Google's co-location facility. If you're not, you are in one of the place where something like Bangalore, Hyderabad, something of that sort. The option which you get is basically called as partner interconnect. Partner interconnect, where it is between your on-premise and a service provider, the partner, and from the partner is going to do the remaining work to connect to the GCP network. So in the first option, the SLA is between you and Google. In the second option, the SLA, the service level agreement, is not going to be provided by Google. It has to be provided by your service level service provider or the partner with whom you are going to work. So if I click on continue, so you have these options. I already have a service provider, or you want to find a service provider. You have options. So if I say I have found out one. So you go ahead and create the remaining steps. You go ahead and create the remaining steps, basically. So that's basically when it comes to partner interconnect. And partner interconnect, if I can just open up this document, there's a very nice documentation on partner interconnect, uh, and there's a comparison also. It's better I show you that. Not this one. 1 minute. Hmm. Yeah, this one. Okay, so when you go to uh, partner interconnect, there is these are the service providers, folks. These are the service providers which you have. So if you want to take in India, so the service providers are these. So Vodafone, Idea, Sifi. So usually a telecom vendor kind of a stuff comes into picture. They jump in here. Sifi. So these are the stuffs which you see. And there is a nice information about how much is the bandwidth they support. I'm not sure whether which document I'm referring to. Service providers. Yes, this one is going to be a good one. 1 minute, folks. Sorry. I had in the slide, but I wanted to show you in the documentation just for your reference. Partner interconnect pricing. Yeah. Okay, so with respect to the partner interconnect and the interconnect pricing, so because we did not see how much of the bandwidth it can support, this could be also a possible question. So I had got it. So partner interconnect, because we don't have that screen in our console to show that. So our dedicated interconnect very clearly mentions how much is the bandwidth supported. Minimum 10 Gbps to 200 Gbps, very clearly mentioned in the UI itself. But when it comes to partner interconnect, right? So partner interconnect pricing. So the VLAN capacity you get is a sub-rate bandwidth. So it's going to be something like it starts with 50 Mbps. You can start with 50 Mbps from 100 to 500 possible. 1 Gbps is also possible. 10, 20, 50. This is the maximum you can have it, folks. So this is the maximum you can have when it comes to partner interconnect. And there's nothing beyond this. Remember that. Remember that. So we'll also add this in our cheat sheet once I show you the partner interconnect details, and we'll put it there. So because this is the max. So if something like you want 80 Gbps or 70 Gbps or even 60 Gbps, the best option is going to be to use dedicated interconnect, basically. Why don't I put that? I'll just put that as a this thing. So partner interconnect supports 50 Mbps, 100 to 500 Mbps, 1 Gbps to 5, 10, 20, and So a good reference material there. So that's where the two options comes, and you also saw the service providers. So referring to the service providers will help you out how you need to connect and all those details. They are going to share the details with you, and the SLA is going to be between you and the service level or the service provider. Now, I guess last time somebody asked a question, how I'm going to, if multiple GCP projects needs to connect to uh, on premise and still want to leverage dedicated interconnect, or basically interconnect partner or dedicated, how will I do, was a question. So that is going to be answered in the next slide. So, and this is a screenshot which I had taken it from one of the official YouTube, which where they were explaining about dedicated interconnect and partner interconnect. The content was good, so I thought let me take a screenshot of it. So basically, dedicated interconnect, all your VLANs comes under the one single organization. So if it is part of an organization, meaning under the organization you will have lots of projects. So one project, usually what I have seen, at least in one of the POCs, so you have an org node. So you may have project one, project two. Now what they usually do is project one, they connect it to, assume, let's use dedicated interconnect for a minute, dedicated interconnect and to on-prem. That's it. Now, if my project 2 also wants to connect to a database, a DB in database, which is in on-prem, but I want to connect it via from a VM which is there in project 2. What could be the option which you can think of, folks? What could be the option which you can think of? Hope the question is clear. So dedicated interconnect is going to be done at an org level. So between multiple, I can have one more dedicated interconnect between on-prem and GCP. That's the simplest and the easiest one, but the most expensive one, because I'm going to have multiple VLANs, which is not cost effective. But with the concepts which you have learned, so you want to have project one, which is going to be between on-prem and GCP. There's a dedicated interconnect, but there's another project called as P2, where is a VM. This VM wants to connect to this DB using internal IP address. What could be the option which you can think? Please change your mode to private mode and send a message so that we will allow everybody to think also. Hope the question is clear, folks. What will you do? You want to save cost, and you can use all your networking concepts which you have gained so far. It is between two projects. Two projects cannot have the same VPC, or sometimes can have the same VPC. How will you do this? There are multiple options. Yes, Anil Kumar, that's one of the options. Anything else which you can think of, Anil Kumar? There are multiple options. Yes, Mangesh, that's another option. Yes, Vivek, that's also an option. Mangesh and Vivek has two different options, but both are going to work. Anything else? Three of you gave answers, three different answers, but all are possible options. Others, folks? Okay, let me give you three options, what Anil Kumar gave, what Mangesh gave, and what Vivek gave. So first and the foremost option, shared VPC. Meaning what I do is I make P1 as a host project. Host project. Host project, you have a dedicated interconnect setup, done. So what else you need? Your P2 is a service project. So only one VPC. So the VM can interact, VM1 can interact with DB over RFC 1918 standard. Straightforward option. Production grade is what I would say. So this is the first option. The second option, which Mangesh mentioned, was VPC network peering. That is also a good choice. VPC network peering, where what you do is you have to make sure that a transitive part is going to be taken and the non-transitive part is going to be taken into picture. So you have something of this sort. Now you have P2, okay, peering may be little tricky here. You have to make sure you do some route parts. So I can use cloud. So if I use peering, so peer P1 network. So if there's a VPC called as VPC2, VPC1, now what I do is do the peering between them, network peering. VPC network peering and do it, but one thing may come into picture basically is you need to have a hop, something like 2 hops from a VM here. You have a VM. This VM can connect to another VM, something like VM 0, something like this. From this VM, I can connect it. So it's going to be a two-step because VPC network peering is non-transitive in nature. So this is one network, VPC2. This is another network. On-premise has another network. So VPC2 and VPC1 are peered, but VPC2 and on-premise is not peered. So I have to take that second, the hop. This is one option. Possible option, and we have seen it. Something like that has worked also. The last option, which Vivek mentioned, was using Cloud VPN. Exactly the same setup, but I don't need a hop or a bastion host kind of a stuff, where I basically do a Cloud VPN. So I don't need this VM. I don't need this VM because VPC Cloud VPN is transitive in nature. So from the VM1 can access DB2. So I can have multiple VPN setup and I can should. The best option, if you ask me in this, shared VPC is the best option because you don't have much stuffs to play around. One network, you have n number of service projects. That's the best option. You have other options just to explore your options, and you can also use a combination. So people if you have some time, I would strongly suggest to do some research on a network model or a design called as pattern, sorry, design pattern called as hub and spoke. Very nice design pattern when it comes to network. It's going to be something like you can try make it as your cycle. So if you see a cycle wheel, so at the center of the cycle wheel you'll have a hub which connects all the spokes, those steel rods. It's not a rod, it's a thin this thing. So those are your spokes. So the center part is going to be your hub. So a bicycle is a very nice example for you to get. So the shared VPC, when you use, it's going to be a concept of hub and spoke model. So do some research, you'll get some nice article. Even in GCP itself you get some articles there. So this is something which is going to be discussed heavily in network engineering, so that's the reason I'm not discussing it here. But if you are interested, look for this one. It's going to be really helpful. So hub and spoke, very nice design pattern when it comes to networking. So where you want to reduce the cost, at the same time you want to leverage all the best features there. Okay, so you can have things shared between the same organization in your dedicated interconnect. So that's something which you can do. When it comes to partner interconnect, the advantage which you get is there are certain organizations who would have acquired couple of organizations. Like for example, two GCP organizations. One is organization A, another one is organization B. Um, is B. So if I just save this uh, interconnect. So if I take something like org A and org B, so there are two organizations, and org A uh, acquired org B. Now assume org A already had some on-prem stuffs also, so they have a dedicated interconnect. So they connect to on-prem. Now after organization B is acquired by them, so assuming organization B is also Google based, it's using Google and they don't have any on-premise, org B cannot connect to on-prem because these are two different networks or two different organizations, to be very specific. So you cannot leverage uh, directly unless you do VPC network peering and also do some extra works. So if you were to have two organization node use the same interconnect, the best option is to work with a partner interconnect because they provide multiple organization support. And what I've heard, some of the special partner interconnect, they also provide you access to AWS or Azure. So if you have AWS and Azure, something they has some of them have that, not everybody. So that's what I heard. So that is also an option. But basically, whenever it comes to interconnect, the option is on-prem to GCP. So you get this option, and the SLA is between your partner and you. Here, the SLA is between Google and you. So subrate bandwidths, we have seen it. So this is a small comparison, so I thought I'll share this. It was just a screenshot of a YouTube video, so a nice way to understand the example. So let me just stop here for any questions, folks, on the dedicated interconnect and the partner interconnect. So the partner interconnect, per my understanding, the only stuff which may come from the exam is how much bandwidth it can support. The Basically 50 Gbps is the max. We saw that in the official documentation also. Here it goes up to 200 Gbps. That's the only thing which I see, because these things you cannot do unless you are very fortunate enough to work on an on-prem to GCP migration or a hybrid model. uh, very less people get an opportunity to work on it unless you work for a very big organization or for a very big customer. uh, any questions, folks? Okay, let's move to the next part if there's no question. Peering. So if I go back to the couple of slides back or to the beginning of our networking, network translation, yeah, this one. So we explored Cloud VPN, good, which is a GCP product. We explored Cloud Interconnect, which has two flavors. Cloud VPN also has two flavors, Classic VPN and HA mode VPN or HA VPN. Cloud Interconnect also has two options, dedicated interconnect. The other one is partner interconnect. Peering also has two options called as direct peering and carrier peering. Cloud VPN and dedicated interconnect options are GCP products. Peering is not a GCP product, it's a Google product. So let's go back to direct peering here. So what is this direct peering? So it's a direct connection which you establish between your business network usually and Google Edge. Google Edge, where you can get high throughput The bandwidth support is going to be around 10 Gbps is what I understand from the documentation. Um, this, as I mentioned, this is not a GCP product. What does that mean in very, very simple terms? You just go to your GCP console, spend a good amount of time seeing whether do you see direct peering or carrier peering. The only peering which you get is VPC peering. So don't get confused. They are two different terms altogether. So if I just search for peering, the only stuff which I get is few things in marketplace, and the only product offering which you get from GCP is VPC network peering, which is only between two GCP networks. But there could be a situation where you want to connect your business network and GCP with a high bandwidth, but you don't have enough budget to do that. So because if you see, the best option is to go with dedicated interconnect. So the bare minimum connection itself is going to take $3,400. So you don't want to set up those VLANs, all those things, but you want basically a box solution. If you want a box solution, direct peering is a good choice, where you have to meet certain prerequisites about there is some specific prerequisite which you need to fill also. Only if you fulfill it, Google is going to share you the details, and you don't need to set up any VLAN or anything. So it's going to be totally free, but only the egress cost you're going to pay. And because it is free always comes with any lots of clauses. One of the clauses, you don't get any SLA. You don't get any SLA. Usually direct peering or carrier peering is going to be using public internet, folks. So you're going to use basically a public IP address to communicate with G Suite, Google, or GCP account to the GCP resources. You're going to do everything over public internet, but the only thing which you get is high throughput, or the bandwidth is going to be little high, like something like 10 Gbps. So if as an organization you want to see this part, I want to get a better bandwidth, I cannot afford too much, then direct peering is a good choice. But since it is having no SLA, if this black box or this box solution does not work, raising a ticket is not going to help you out. So you have to wait. Google is going to fix it, but when, you have to wait. So you cannot raise any tickets. Even if you raise it, they're going to give you a standard response saying that we are working on it, you need to get back. So basically by default, the next hop is going to be your internet gateway. So you're going to rely on your public IP address or on the external IP address. If you want to do something like with the direct peering also, I want to use internal IP address itself, then you have to have a tunnel, a cloud VPN tunnel setup, and then you do it. So two options, but by default, it's going to be usually using external IP address. The only option which we are exploring till now is direct peering, which leverages external IP address. Every other services which we have seen right from the beginning, shared VPC, VPC network peering, cloud VPN, dedicated interconnect, cloud NAT, private service access, private Google access, all those things were primarily on internal IP address. This is the only product which expects to have an external IP address. And a quick comparison between dedicated interconnect and carrier direct peering. So this requires GCP, meaning if I were to leverage dedicated interconnect, you should have a GCP account. You should have a GCP account, and it should be having an organization. Only then you are going to leverage it. So you cannot leverage it in a free trial account, first of all. When it comes to direct peering, you don't need to have a GCP resource because it's a Google product. So you can do the peering between your G Suite and your on-premise if you have something of that sort, or anything related to any Google products and your on-premise. If you want to do it, you can use direct peering directly here. And when you use direct peering, usually what I have seen is people who use only G Suite leverage G Suite to a great extent, are the people who use G Suite. So people who use G Suite leverage direct peering to some great extent. So when it comes to dedicated interconnect, it does not give you access directly to G Suite. So don't get confused here. So when you're using direct peering, there's a chance that you can leverage G Suite or Google Workspace. When you are, and because this part, the left hand side, which you see, this is a GCP offering. So you don't get access to other Google services, paid services like Google Workspace or G Suite. So when it comes to dedicated interconnect, you need to buy those VLANs, which is going to cost you. But when it comes to direct peering, there's no cost. It's totally free. There's no cost. Here, there's no SLA. Here you get 99.9 SLA. Dedicated interconnect is primarily on is a layer 2. When it comes to the OSI model, it's a layer 2. Carrier peering, if I'm not wrong, it is layer 3. Layer 3. So those are the differences. And if you are interested in dedicated interconnect, create an GCP account with an organization node, go fill the form, you get it. If you are very close to one of the co-location facility. But if you want to have try direct peering, you have to fill this form, folks. It's not in GCP. It's not in GCP, but you have to go fill a form. Fill a form called as in this website. So it's there in the module 5 bookmarks, where peering is a direct interconnection between a Google's network and another network to support exchange of traffic. So you have to submit your peering request. Fill in the form. Lots of information is going to be there. Fill the form, and only if you meet their criteria, then they will share the details. So, and this is totally outside of GCP. It is a Google product. Okay, so don't get confused there. Similarly, when it comes to direct peering, right? If you are not very close to one of those facilities which Google provides, you have alternative options similar to your partner interconnect. So similar to your partner interconnect, you have something called as carrier peering. You also have a carrier peering. So you work with a carrier with a service provider. So you have options. So totally, I would say, if I do a comparison, there's going to be 6 options which you get between on-prem to GCP if you were to do. So cloud VPN, classic mode, cloud VPN, HA mode. Then you have dedicated interconnect. Then you have partner interconnect. Then you have direct peering. And you also have carrier peering. So 6 options or 5 options. If you say cloud VPN, classic and HA are going to be same, so it's going to be 5. You take a call how you want to mention it. But these are the options which you get when it comes to on-prem to GCP. Basically, you get these options. So it's good we compare it in a comparison page so that we know when to use it. So I'm not a great fan of this, and we cannot even try it, and we cannot even see it. But at least the remaining 4 we can definitely give a try. Give a try in our console, not filling completely, but to some extent we can give a try. And basically, the easiest one to test it is classic and HA mode VPN. So let me just do a small comparison between all the 3 types of options: cloud VPN, interconnect, and peering. So the type of access type, VPN and interconnect, is the same. It's going to be based on internal IP address, RFC 1918 standard. But when it comes to peering, it's going to be using public internet by default. If you want a private IP address or internal IP address, you have to leverage cloud VPN. So by default, it's going to be external IP. So that's the reason I have put it in red color. So when it comes to capacity wise, one tunnel can give you up to 3 Gbps. 3 Gbps is what I see. So last week Vivek was mentioning it is going to give 12, so I have not seen it. So I'll see it, folks. Sorry, I did not see it. Um, I'll check it and update the slide. If it's 3 Gbps, good. So if it's 12, I'll update it. So that's the capacity which you get. But it's going to be over public internet. The connection is encrypted, but it's going to be over public internet. When it comes to dedicated interconnect, you get a flavors of two flavors basically: partner interconnect, dedicated interconnect. In dedicated interconnect, you can get multiples of 10, up to 80, or multiples of 100, so up to 200 Gbps. Here, I have very less documentation to explore this. So direct peering only supports per link 10 Gbps. What is the max? I did not get that information from the documentation. Per link, you get 10 Gbps, meaning if you compare it with VPN itself, the capacity provided or the bandwidth is going to be little better, but it's using public IP address. That's the important thing. So capacity via partner, nothing for VPN, but for your partner interconnect, you can have the same thing, the one which we mentioned in our cheat sheet. So carrier peering, you have to contact. There's no straightforward information. So every carrier is going to provide different capacity. You have to contact the carrier, the provider, and get the details there. So it is going to totally depend on the network provider there. Pricing wise, each tunnel you are going to charge. The gateways which you create will be charged, and the outgoing traffic, the egress outgoing traffic from your VMs is going to be charged. Same thing that is the case with your interconnect. So egress cost is going to be there. Egress cost is always going to be there, irrespective of what is the kind of service which you're going to use. Along with that, the VLANs which you set up between your co-location facility, GCP's co-location facility, and uh, your on-premise. When it comes to peering, right, establishing a direct connection, peering connection with GCP is free. That piece is free, but what is that which you will be charged is basically the egress cost. The egress cost. The SLA is another important thing for big organizations. So peering may not be a good choice because there is no SLA, which is going to be a red flag. But when it comes to dedicated or part interconnect, so specifically the dedicated interconnect, I should have mentioned it as dedicated interconnect. They provide 4 nines of SLA. HAVPN provides 4 nines of SLA because there is a redundant tunnel there. When it comes to classic, it is only 3 nines of SLA. The OSI layer, if you are interested, so cloud VPN and peering are at the layer 3, the network layer. Interconnect is going to be your layer 2, which is your data layer. So a small comparison so that you know when to use what. So basically you go most of the time with this capacity. Based on this capacity, you go decide the stuffs. Okay, so that's a small comparison. And there was a nice article, like usually, right, so far we have seen n number of decision trees, at least 3, sorry, at least 2, not n, 2 decision trees, one with our compute options, one with our storage options, and since we are doing our networking, so why don't we look into a net decision tree with respect to networking itself. So this is again taken from the Google blog. First, the question is, I need a private to private connectivity, meaning internal IP address to internal IP address. So if I say yes, you ask the follow-up question: bandwidth and performance of the current connection is okay. If you say yes, the bandwidth is okay, then simply use VPN. Simple. Private to private. If you say no, bandwidth, what bandwidth I get is very less, I want something better, then you ask a follow-up question: can you manage the equipments, those Ethernet, VLAN, all those things, and connect to Google points of presence or co-location facility? If you say yes, you have an answer to use with dedicated interconnect. Straightforward. If you say no, I'm not close, I cannot manage all those things, then you have the option of using partner interconnect. So the top, if I take my highlighter, This one is internal IP address, folks. The RFC 1918 standard. So internal IP address. The bottom part is basically when you want to use peering, the options of peering. So bandwidth and the performance of the current connection is okay. Meaning just use your public IP address and continue working on it. If you say no, I need more, then you again ask the same thing. So are you close to the co-location facility? Then you go with your direct peering. If you say no, go with your carrier peering. So this is basically a decision tree related to those on-prem to GCP kind of a stuff. When you want that, you use this decision tree. Okay. So now I have created a it is so I have created a small recap again based on the various feedbacks which I got from the various trainings. So I have created a recap because networking is slightly difficult to digest for people who are not from the networking background. So a small recap. Please everybody put your mode into a private mode so that you only respond to me, not to everyone. Um the first question, I need to establish the connection, and it is assumed if I don't mention the connection between the network, it is assumed that it is going to be using internal IP address, folks. RFC 1918 standard. So communication between virtual machines in the uh, same VPC network in same project in same organization. If I were to do, meaning I have VM1, VM2, they belong to a VPC called as XYZ, they belong to a project called as ABC, and they are in an organization called as organization A. Now if I were to do it, so just to give you more heads up, so organization A, project A, VPC, VPC A, I have VM1 and VM2. So they have to use RFC 1918 standard. This is the stuff. If this is the kind of requirement, that is what has been asked here. Communication between virtual machines in the same VPC network, in the same project, in a same organization. What is that you need to do, folks? What VPC option you have to set up for this? If you were to achieve this, if you were to achieve something like this, what will you do? So let me scroll this down so that you can see the question and also the option. What should you do, folks? This is the requirement. VMs in the same project using the same network need to communicate using internal IP address. What should I do? No response. Okay, good, Vivek. If you can more elaborate it. Anybody else? The most basic one, folks. Don't get suddenly worried. Yes, Anil V. So that's correct. No, Mangesh, that's not the one. Yes, Vivek, that's correct. You have emphasized on that. Yes, if you want to emphasize more, it's going to be good, Vivek. Uh, uh, Anil B and Vivek has got it so far. The most simplistic setup which you can get in GCP. This is the most simplistic setup, right? Everything else is going to be a little complex. So I would say, if you ask me, assuming I use default VPC, nothing, no action. I would say no action to be taken. So I use my default VPC, that's it. Or if I use a custom VPC, I will use something as as Vivek mentioned, I'm going to use a firewall rule. If I use default VPC, no action to be taken, folks. It is going to be already there. Firewall rules is open. I just create two virtual machines with internal IP address and start working. It's going to work for me, right? If it is a custom VPC, then you have to explicitly open up your SSH port, any other ports. Straightforward option there. Hope this is clear, folks. You don't need to do anything different. So just because it's in the same VPC. Same VPC, you can have VMs communicate. You don't need any setup, extra additional setup. That is the basic thing here. So hope it is clear, folks. No need of any shared VPC, no need of cloud VPN, no need of interconnect, VPN, all those things. Standard, simple, straightforward option. Now the next question is communication between VMs in the same VPC, but the VMs are in different projects, but they are in the same organization. So it is something like this. So same VPC. So organization. Okay. Before I start explaining, people started answering it. Okay. So same organization. I have an organization. I have a VPC called as VPC A in a project. Yep. Anil Kumar, Anil B, Mangesh got it. So I have a project called as VPC in a project called as project A, but there is a VM1 in project B, VM in project C. VM1 and VM2 needs to interact. What will you use? What is the option? That is what has been asked in a very simplistic one-liner. Only 3 of you got it. Others? Communication between VMs in the same VPC network, but these VMs are in different projects, but they fall under the same organization. So answer is anybody else wants to answer? Yes, Vivek also got it. Vivek, Mangesh, Anil Kumar, Anil B got it correctly. So basically shared VPC, folks. One network, but it has to be accessed by multiple uh, VM service projects. Then basically your shared VPC. So the next option, communication between virtual machines in different VPC, but they are in the same project in the same organization. So org A, project A, I have VPC A, which is having VM1. I have VPC B, I have VM2. So VM1 should connect with VM2. Please be very specific with the name. So don't use any short forms. I would strongly expect you to give a proper name. Thank you, Vivek. So because it's going to be really confusing if you start using those names. Vivek got it. This is the step. This is the requirement. So yes, Anil Kumar. Sorry, Anil B. That's correct. Others, folks. Yes, Mangesh, that's correct. And I like the complete name which you gave, Mangesh. Others, folks. Folks, others are quite, I see like around 4 to 5 people respond. Others are quiet. So give a try. So it's between only 10 of us or 11 members of us, right? So there's nothing going to be wrong there. So don't worry. Give a try at least. Even if you have not attended the previous class, give a try with the concept which you have learned. So give a try. So being quiet, I guess, uh, is not good for you. Basically, that's what I would say. So you have already paid. So be little interactive so that make mistakes. That's okay, right? It's not going to be exam. I'm not going to evaluate you here. So uh, give a try. This is a very standard one which we have done good number of times. The response simple, folks. VPC network. Yes, Anil Kumar. So VPC network peering is the option. And with Cloud VPN also I can do it. Cloud VPN also I can do it, but there's an asterisk which I put, more like conditions apply. It's an expensive solution. If you say it's going to be expensive, but VPC network peering, VPC network peering is the best name I will use. I will not use VPC peering. I will not use peering, because there's another product which is going to confuse us. So that's the reason from the beginning we have stick to a name, very proper name, official name, VPC network peering. So I can also do with Cloud VPN. We have done that, but the tunnel creating, the setup, then our gateway, this is going to make the solution little expensive. Good. Communication between virtual machines in different VPC. Last time it was same project. Now the VPCs are not in the same project, but they are in different project in the same organization. What will you do for this? So the only change from the previous question to the current question is, there it was same project, now it is different project. What will you use? What will you use? I would expect everybody to answer now at least. Same setup, but now the VPC B is in project B. It's in project B, folks. How will you do? Yes, Deepak, that's correct. Mm, one wrong answer. Different VPC, meaning two VPCs are there, two different projects are there. In the project you have VMs, they have to interact each other. So different VPCs, folks. Yes, Vivek, that's correct. Others? Mm, yes, Kumar, that's correct. Others, folks? Same solution, folks. It's the same solution. Two different networks. So here it is two GCP networks. If I were to communicate, cloud VPN or cloud or VPC network pairing are the good options. One is going to be expensive, that's okay, but options are possible. So it is the same answer. Same answer. It is like the same answer is same, but the questions are going to be different, right? That kind of a format. So whatever you ask, it's the same thing. Uh, so it's just a tongue twister kind of a stuff. So people ask in different forms, but the answer is going to remain the same. Okay, the concept is simple. Two GCP networks, that's it. As long as it's a two GCP network, I have an option easily to set up. Now let's try to make it little more complicated. The communication between the virtual machines in different VPC, okay, in different project, that is also okay, but not in the same organization. Now it is between two different organizations. What will you do? So two GCP networks, but present in two different organizations altogether. What is the option which you are going to do to set up those VMs to communicate using internal IP address? Yes, Vivek, a complete answer. Others? Yes, Mangesh, that's correct. Partial answers also acceptable, folks. Give a try. Trying is the most important thing. Not sure what is the reason. So only two responses. Same answer. Same answer. Two GCP networks. As long as it's a two GCP network, whatever the tongue twisting which you do is going to work the same for me. So two GCP network, whenever I hear the term 2 GCP network, simple, cloud VPN or cloud VPN or VPC network peering, nothing else. Simple, simple. So and please don't use peering as the term because you'll get confused. There is two. What peering? Is it direct peering, carrier peering, or VPC network peering? I don't know why Google uses the same name for confusing people. So, but don't use the term with just peering. It's going to confuse people. Okay. So the next option, communication between GCP. Now all these options above was between GCP only, the comfort zone. Now the following questions are going to be between GCP and on-premise. So communication between GCP VPC and on-premise network or other cloud network like AWS, Azure, or another GCP network. How will you do it, folks? GCP and non-GCP network, GCP and GCP network, both I want to do. How will I handle it? Yes, Vivek, that's correct. Yep, Anil Kumar, that's correct. No, one wrong answer. I'm the most greediest person in this requirement. So I want GCP to on-prem, GCP to other cloud, GCP to GCP, all the combinations I want. The most greediest option. No, couple of wrong answers. Anil Kumar and Vivek got it correctly so far. All the combinations if you want to get, or uh, the ultimate option which you can get. With this option, you can do everything. That's what I would say. GCP to GCP to on-prem, how do you? GCP to AWS, how will you do it? So it has to be only cloud VPN, the ultimate option which you can have. Everything is supported now. Every option is going to be supported. AWS to GCP, possible. GCP to on-prem, possible. GCP to GCP, that's the demo which we did. So that is also possible. And the advantage which you get is that transitive nature is going to be an advantage. Okay, so moving on to the next question. Connectivity between GCP, and I'm very precise here, between on-premise only on-premise with extremely good connectivity. I need a very good extreme connectivity, so not like peanuts. I need a very good connectivity between on-prem and GCP only. Very, very specific. Vivek and Kumar got it correctly. Mangesh got it correctly. Anil B got it correctly. Anybody else? Very specific, GCP and on-prem. And very good connectivity. So it's going to be your interconnect options. Cloud interconnect. So where it can be a dedicated interconnect or a partner interconnect. Either one of them is going to get very good bandwidth. So in partner interconnect, I can go up to what? Uh, 50 Gbps. In dedicated interconnect, I can go up to 200 Gbps. Good. And the last option, communication between GCP and on-prem. Okay, we already mentioned it. So 50 Gbps, not 50 GB for Kumar, 50 Gbps. Uh, um, Communication between GCP and on-premise network via public IP address, but still want a better connectivity here. So Vivek, Mangesh, Kumar got it correctly. Others wants to give a try? Just now we finished it, folks. Peering, direct peering. So I have to update it. It has to be peering. It could be a direct peering or a carrier peering. It's going to be using public IP address. It's going to be using public IP address. Simple. So either one of them. It's not direct peering or carrier peering. Either one of them is going to work. So to be very specific, giving a name like carrier peering is going to be good. Okay. So that was the recap, folks. What we did for almost like 3 weeks if I'm not wrong. So networking is a little broad, so that's the reason we are taking our sweet time to finish it off. So that's a recap, and still networking is not over. Okay, so I would say we are 60% done. We have few more stuffs. So now we saw the various connectivity networks, all those things. The next part which we are going to do is we did a little bit in our virtual machine class, in our Kubernetes class. Now we will do it in a full-fledged fashion, where we are going to see basically the various load balancers which is available in GCP. And we have seen a global load balancer, but and in our Kubernetes class we had seen a network load balancer, but there are other few load balancers like uh, HTTPS is the one which we saw, SSL proxy, TCP proxy, internal HTTPS load balancer, internal TCP UDP load balancer. So totally 6 load balancers are available in GCP, and these load balancers are heavily used by virtual machines Kubernetes cluster, by storage, and of late they have also provided support for products like App Engine, Cloud Run. Also for serverless products also they have given some support. So why, we will discuss that as we progress. So we'll take a 10 minutes break. Once we come back from the break, we'll explore the various load balancer concept, uh, and also do a very comprehensive demo. So I would say this could be one of the most comprehensive demo which we are going to do in our class. So where we are going to combine lots of products and do everything. Okay, so mostly tomorrow is what, or today itself we should be able to do it. Once we finish the concept, we should be able to do the demo. So after load balancer, we will talk about cloud DNS, we'll talk about cloud CDN, and we'll combine all the three combinations and do a demo. Load balancer, DNS, and CDN all combined together will have a website. At the end of the day, we will have an HTTPS www.example.com, something of that sort, a website running at the end of the class today. Okay, that's the plan. So before we look into that, let's take a 10 minutes break and come back, folks. Let me start the timer. I'll just close all these things. So take a 10 minutes break and come back, folks. I'll stop the recording.
This conference will now be recorded.
All right, before the break, we finished all our options where we connect between two different networks. That's all good. Once you have connected everything, good. Now there's going to be some kind of workloads which needs to be handled by multiple VMs or Kubernetes cluster or any other options. So you definitely need to have a kind of load balancer which balances the load uh, across multiple regions, sending the traffic to the healthiest virtual machine whenever it is required. Scale up, handle heavy traffic, route the traffic to the closest healthiest virtual machine. So these are all the tasks which a load balancer does. Um, we'll explore more about load balancer in from now onwards. And when it comes to load balancer in GCP, you can categorize it into you will have 6 different flavors of load balancer, and you can easily categorize it into like how the traffic comes from, what is the presence of this global load balancer, sorry, what is the presence, or where the scope, whether it is global, regional, or multi-regional, we can easily distinguish based on that. So you can categorize it as, and where the traffic comes, whether the traffic is going to come from an external source or from an internal source. So these are the criterias which you can help which can help to categorize the stuffs. The first category which you see is global, meaning these are going to have a global presence. So these are global load balancers. So definitely helpful when you want to have a website which is going to have a global presence. So global and external, meaning the traffic is going to come from an external source, from internet to this load balancer. So under that criteria category, you have three load balancers. And these are all proxy load balancers. So HTTPS, SSL proxy, and TCP proxy, based on the kind of traffic, you're going to decide which is going to be better. So if it's an SSL traffic, you're going to SSL. If it is an TCP, you're going to use TCP. And if it's a standard HTTP or HTTPS, you're going to use HTTPS load balancer. And these are all proxy load balancer because there's going to be a proxy in between, which is going to change the source IP, basically. The second type of load balancers which you get is called as regional and external, meaning these are not going to be having a global presence. The anycast IP concept will not be applied here. So these are regional presence. So the external IP address. So all these things at the end is going to create an IP address, right? So when you have a global load balancer, the IP address, the external IP address is going to be having a global presence. So when you create a network load balancer, this is a regional external load balancer. So the one which we did in our Kubernetes class, the various services which we explored, cluster IP, node port, uh, then load balancer and ingress we tried, right? The ingress is nothing but your global load balancer. The load balancer option, the service type of load balancer, that is nothing but your regional network load balancer, which is going to get traffic from the external source, but it's going to be within that region, So it does not mean if I create a Kubernetes cluster in Mumbai and I have a load balancer, a regional load balancer created, if the traffic comes from Switzerland, will it not handle? No, it's going to handle it. Only thing is that the latency is going to be little more. But if you have a global load balancer, the latency is going to be less there. That's the basic stuff. So this network load balancer is not a proxy load balancer. It's a pass-through load balancer. What is that? We'll understand in the next few slides. It's a pass-through. So it's not going to proxy your request or terminate your request. So it's a pass-through. It's just a pass-through load balancer. And the last type of load balancer which you get is regional and internal, meaning it's going to be in a specific region and the request does not come from outside. It comes from a virtual machine or from a Kubernetes cluster. So the request comes from an internal source. So think of the MIG demo which we did. So what we did was a stateless demo. So it just had VMs to just serve a static content, but not every time it's going to be like that. So you need to have a database behind the scene. So maybe in your to serve your static content or your website, you may have 20 VMs, but all the 20 VMs, if they start sending to one single database, the database may crash. So instead of that, you do the traffic split internally to route it to a specific database. Maybe you may have multiple databases. So that is where this internal load balancer comes very handy. And the recent addition to this was internal HTTPS load balancer. So previously it was only internal TCP and UDP load balancer. Now recently they added even HTTPS load balancer. So 5 or 6 different types of load balancers based on global presence, the presence, and the type of traffic you get in. So we will explore one more time HTTPS load balancer. Network load balancer, we already explored it a couple of times, so I'm not going to explore again. But we'll see the concepts of SSL, TCP proxy, and HTTPS, internal HTTPS load balancer concepts. Okay, so a summary of what we are going to do in the next few minutes. Type of load, and this table is really awesome table, I would say. For my network engineering, this table was really helpful. So not for cloud architect, for my network engineer. So a nice table, and this is a table exactly a copy paste of what is there in the official documentation. The types of load balancers. So if it's HTTP, traffic is going to be HTTP or HTTPS. The ports which it supports are only these standard ports, no other ports. The presence is global and it is external load balancer. Simple. If it is not a HTTPS traffic, it could be either SSL or TCP. So if it is of that sort, you get two more flavors at a global level. So one is called as SSL proxy, where you get an option called as TCP with SSL offload. So what do you mean by this? What is basically an SSL offload? So SSL means secure socket layer, right? So basically there's going to be a concept where you need to encrypt the connection, decrypt, all those things. Some heavy CPU and memory intensive operations are going to be there. So if you get an option where you can do the offload, the SSL activity, what is this going to do is the resource intensive task like encryption, decryption is going to be handled by some other system or by a dedicated system, not by your load balancer. So the load balancer is not going to do that part. So that is where you get SSL proxy option, and the ports which it supports are limited, folks. Limited. 25, 43, 110, all those things. So, and if you do a quick search on these ports, most of these ports are related to, and there are few more ports supported now. Most of the ports, I just did a small lookup in the Wikipedia and created a small slide here. So most of the ports are related to email service, SMTP, post office protocol, IMAP, uh, post POP over TLS, SMTP over TLS. Most of them is what you see like this kind of a service. So that's your SSL proxy if you wanted. So when it comes to TCP, where there's not going to be a SSL offload, it is not going to be there. So meaning the load balancer itself should do the encryption decryption. There's going to be a little overhead for it. So now if you see also, we are going down in our stack OSI model. So we are coming to TCP layer here. So because HTTP, SSL, TCP, these are all proxy load balancer. Proxy, what is going to happen usually is the connection is going to get terminated. There's going to be two layers. At one layer, the first layer, the connection is going to get terminated and a new connection is going to be created. So meaning if you use any of these three load balancers, you will not be able to retain the client or the source IP address. What is client IP address? So for example, if I open up a website from my mobile phone or from my laptop, there's going to be a source IP, right? What is my IP output? That is going to be my source IP to my load balancer. So these load balancers will not be able to retain it unless you have done something programmatically to retain the IP address. Why this IP address is important? Maybe you want to do some statistics. From the IP address, you do a lookup and find out where the request came from. So if you were to do all those kind of stuffs, you have to do some extra work with these load balancer, retaining it in a header, doing some extra works. But because they are all proxy load balancer, basically that is a key part. And the advantage which you get is these are global. So any cast IP concept you are going to get when you start using it with DNS and all. The fourth one which you get is a network load balancer. Here it's not a proxy load balancer, it's a pass through. So it is going to preserve your client IP address. So it's going to preserve a client IP address, and there's no restriction on any ports. Any ports you can use it, but the presence is regional. Presence is regional. Similarly, you have the internal load balancer, which is going to be uh, any port support basically, and the request comes from an internal source. Lastly, for your HTTPS, only few ports supported, but the request comes from an internal source. Now let's look into some of the architectures, how these load or the flow diagram of how these load balancers work. Then you are going to really appreciate a few of the load balancers. And whenever possible, a rule of thumb which I would say is try to use layer 7. HTTPS is a layer 7 load balancer, the topmost layer in your OSI model, the application layer. So try to use layer 7 as much as possible. The only reason is it's the smartest because it is on the topmost layer. you get more information for routing, how the traffic has to be routed. But if you go slightly down, say for example in layer 4, the network load balancer, L4 load balancer, you will not have much information for routing. So when you come down the layer, so always prefer to use, wherever there's a possibility, prefer to use HTTPS is what I would suggest. Let me just show you a flow, how the global load balancing works, all those things. So first, as an end user, you open up your browser, send a request. The moment you send a request, there's going to be an IP address and a port. So a global forwarding rule is going to come into picture. It's going to forward that request. Then you are going to have a proxy where the URL mappings are going to be there. So if this is the kind of request, how should I send it? To which backend I should send is what you are going to decide it here. So the host and path mapping, you're going to do it here. So based on those configuration, it's going to hit a backend service. The backend service could be a storage bucket, could be a instance group, could be a network endpoint group. There are lots of options, and there is also some serverless options which they have introduced now. So it's going to hit a backend service, which is going to be basically these things, virtual machines, all those things. And you apply firewall rule only for your virtual machines, not for your load balancer. Please remember that the firewall rule which you apply is only for your backend services. For a load balancer, how to apply a firewall rule, we will see it in tomorrow's class. So this is the flow for your HTTPS load balancing. So there's going to be a proxy here. The connection is going to be terminated and a new connection is going to be created always. So that's the reason all those global load balancer, HTTP, SSL, and um, TCP proxy. So basically, these are all global load balancers. So the connection get terminated. So to show you that connection termination, right? This is the beautiful flow again from taken from the official documentation. So you're going to have two connections, folks. Whenever you are working with uh, global global proxy load balancer, HTTP, SSL, TCP. So this is something with respect to SSL proxy. The traffic is SSL. You see that padlock. You see that padlock symbol here. The request comes from Iowa, US Central, or Boston, and it's going to be an SSL traffic. So first, when it reaches the first connection, it reaches the load balancer. The connection is going to be terminated, and a new connection is going to be created from your load balancer to your backend system. This connection too is the most important thing, folks. If you are working on any RFPs or tender document, usually they will mention, the customer will always ask for more. They will mention end-to-end encryption. If they mention end-to-end, meaning the time the request originates from the end user till it reaches the Google ecosystem, till the last layer, it should be encrypted. So if you see this in this diagram, it is not end-to-end encrypted. From my end user till it reaches the load balancer, which is Google uh, component, it is encrypted. Fine. From my load balancer to my virtual machines, groups of virtual machine, it does not need to be encrypted because it's an internal communication, right? You can make it unencrypted. It's okay. But if the customer emphasizes even this has to be encrypted, you can encrypt it. Encryption is always an overhead, so everybody knows that. So if the customer says it's okay, then you don't need to encrypt it. But if they say end-to-end encryption, even this piece from your load balancer to your backend, you have to encrypt it. And now a very important component to understand, or the concept to understand here, is uh, the end user never ever touches the VMs. They don't need to know the details of the VM. Plus, you don't need to have an external IP address for these VMs. Basically, you can have so you need to have an external IP address for your load balancer. That's enough. That's how the end users try to connect it. From your load balancer, the load balancer should have some net blocks. Usually they are going to call as some specific CIDR range. If you only open up those ports, right, that is good enough for the load balancer to find whether the groups of VMs are healthy or not. So basically we are going to do a demo which is going to be on the similar lines, where I will not have any firewall rule in that VPC like 0.0.0.0/0. So I'm going to have something very specific ports where the load balancer connects to my internal resources like groups of virtual machines with a specific block called as health check probe. So that way I'm trying to make it more secure, and you never put a firewall rule uh, to block users at your VM level. You put firewall rules, something called as cloud armor, which we are going to see in tomorrow's class, uh, at your load balancer level, layer 7 load balancer. The firewall rules which you put are going to be basically layer 3, uh, layer 4 load balancers. Sorry, my bad. Layer 4 firewall rules which you put. Usually the firewall rules which we put. Layer 4 is a TCP network layer. Sorry, it should be layer 3 load balance, layer 3 firewall rules. All the firewall rules which we are putting so far is in layer 3. Tomorrow we'll see how we can put a layer 7 load balancer using our cloud armor. So connection gets terminated. Because the connection get terminated, you have to basically, if you were to retain the user from Iowa, the IP address, when it gets terminated, make sure there is some kind of a application written in such a way that the user information, the client IP address or the source IP address, is added in the header. Only then you can send that information. If you were to put some restrictions like that, only if the request comes from US, you have to do it. So that is something required. So otherwise, if you say no, I don't need it, so the IP address is not going to come there. So what you get as a request to your MIGs are always a request from your load balancer. It is not so. If you whitelist what IPs should come to your MIG, that is good enough, folks. The whole reason why I'm explaining this is you don't need something called as 0.0.0 anymore. That's a key part, because the request comes from your load balancer, not from the outside world. So load balancer should only need to know how to communicate with the MIGs. Okay, so hope that is clear, folks. Any questions on this part?
So Mahesh, if I wanted to do the full encryption till end, we can still do with this SSL proxy also, right? That's what you said,
Yeah,
right?
you can do it. You can do it. So by default, it will not be encrypted, but if you want, you can encrypt it. So the internal communication, you can make sure it is encrypted.
Okay, thank you.
Yeah. All right. So moving on to the next one, if the traffic is not SSL, if it's not SSL, what's going to happen? Basically, it's not going to have a padlock. You're not going to have a padlock. Uh, it's going to be TCP. Remaining everything remains the same. Only it is not encrypted, right? Some kind of workloads where you don't need to have this overhead of encryption, you can use TCP proxy. Maybe a quick proof of concept or something is going to be a good choice. It's the same thing, except it is not a SSL traffic, it is a TCP traffic. Same thing. So connection again terminates here and a new connection gets created. The next kind of load balancer which you get is basically the network load balancer. The network load balancer which you use, the regional one. So how this looks, basically this is going to be really helpful when you are doing something with Kubernetes and all. It's going to come handy. So here what you are going to do basically is, as I mentioned, network load balancer is regional in nature, and it is a non-proxied or pass-through load balancer. There's no connection termination, new connection created, because it's already regional. It's already regional. So user comes from California. They hit a load balancer. It directly reaches your MIGs or groups of servers. So it hits it. You get a response directly. Similarly, if you have user from New York, they hit a load balancer, they get the things served. So very simple option here. There is no concept of proxying here. So if you want something only a website which is not going to have a global presence, only a local presence in a specific city, network load balancer could be a simple straightforward option. And in the service type in our Kubernetes, when we made the service type as uh, load balancer, this was the exact one which got created. So there's one question, with SSL, are the client certificate needed to be included with the load balancer? We'll talk about that, Aman. Yes, it is required. So you can have the SSL certificate created. So we will do the demo also. We'll also do the demo where we create a managed SSL certificate and then load it. Yes, it is required. If you don't want, it's going to be normal HTTP. In your SSL, definitely you need to have the certificate. And the last one, where you use a combination. This is, I would say, the next slide is also one of the best slides, I would say, with the images. So if you want to use a combination of load balancer, for example, HTTP plus internal. So people from various parts of the world hit your global HTTPS load balancer. From there, the global load balancer knows smart if the request comes from US or any part of US, all the requests are going to go to US Central. That's what you have basically. And if it comes from any part of Asia, it's going to go to Taiwan. So you have MIGs here. So this is going to be your 100.1.1. This is your external global load balancer's IP address. Once it reaches this one, right? And we had done only this part of the demo only. So the demo which we did in our class was only this part, a stateless application. Now, if all this request goes to one database, the database will crash. And also there could be some requirements that if you have a global presence, users from US, you may store some extra information. Users from Asia, you may save some other extra information. So what you can do is you can have uh, region specific or continent specific databases where the traffic, if you see the traffic from here, if it goes to the VMs, it's an internal traffic. So you're going to use your internal load balancing. So here the IP address which you're going to use, you see it's a internal IP address, RFC 1918 standard. So it comes here. There you use some kind of a middle tier or anything. From the middle tier, it's going to hit your database. So this way, the traffic, if it's coming from internal source, it's going to be basically an internal load balancer. And based on the type of traffic, it could be TCP or HTTPS load balancer. Simple. So this is a good slide, I would say. Usually I have heard that from many people that this internal load balancer is something new. So most of the time in on-premise, you would have seen something like a global load balancer, usually FY kind of stuff. So this is going to be something like a standard on-prem stuff is going to be FY load balancer, very popular one, which is a hardware based one. But here the load balancer which you get is totally software driven. uh, SDN, software defined network. And you don't need to do any pre-warming and all. Say for example, tomorrow there's a promotion or a launch, you expect a huge traffic to come to your website. So if it is like FY kind of a stuff, you pre-warm it. So start it up, do all the pre-warming like a warm-up which you do with the morning time. So you need to be, it should be pre-warmed. And if it's something crashes, you should have some other hardware, all those things. But when it comes to the load balancers which Google provides, these are all software defined networks. So it's fully managed by Google. No pre-warming is required. Huge load comes, it scales up. Something crashes, there's an alternative which Google brings up for you. So that way your the effort to manage a load balancer is going to be very, very less in GCP. And the last one, slightly comprehensive architecture, which tries to see a three-tier architecture here, where combinations of the stuffs are used. For example, if I take my highlighter, request comes from California. It first hits a HTTPS load balancer. So then based on the closest proximity, it's going to go to either to US West, Central, or East. So this is your MIG, Managed Instance Group. So this is where your web tier is going to be there. From the web tier, it's going to go to a internal load balancer because the traffic is coming from an internal source, your virtual machines. It's going to hit a middleware, again a instance group. From the middleware, it's going to use another internal load balancer and send it to a final database. So you can see how the previous slide and this both are same, but the whole intention here is it uses a three-tier architecture. It has a web, it has a middleware, and a database. So you can use internal load balancer heavily in this context. So I had not got an opportunity till now to use internal load balancer in any of the projects which I did. Planning to do one demo myself. So once I have the demo, so I tried to use this internal load balancer in one of the small experiment where I wanted to do a load balancing between two Cloud SQL instances. So like how you do the load balancing between virtual machine, I wanted to do a load balancing between two Cloud SQL instance, because if you see the Cloud SQL instance which you get are basically zonal. So what if I want to have a balancing between two Cloud SQL instance? So I was trying to do, so I'm not fully successful there. So if I get it successful, I'll definitely create a video in the YouTube and share it with everybody. So that's where the internal load balancer comes handy. So it's more of exploration. So this is for most of us, internal load balancer itself would be something new, because most of them would have heard of global load balancer or FY kind of load balancers. Internal load balancer itself is little new, and even if you look into any official materials like quick labs, all those things, I have not found any demos on internal load balancer, unfortunately. So there's no demos there. So a demo is something which we have to create it our own. So maybe something like two Cloud SQL instances, you want to do a load balancing, internal load balancing, could be a good choice, could be a good choice. So that's something on the load balancer. We will do a demo on this load balancer because we have already done a couple of times demo. So I'm not going to do it one more time, but I'm going to do later comprehensively covering all the stuffs in one comprehensive demo. The next concept, which is going to be very important, is a DNS, which helps us to cloud DNS, which helps us to translate any domains like www.myapp.com. If you have something, it needs to get translated to an IP address. This IP address could be a regional load balancer, it could be a global load balancer. It has to be an IP address, basically. In some cases IPv4, in some cases IPv6. So because humans cannot remember numbers very easily, so you need a domain. So that's where this DNS comes handy. And one thing which every cloud provider does with when it comes to DNS is they try to make sure, I guess even in AWS this is the same case, they make this service 100% available. The SLA, it's a promise, and it's very clearly mentioned in their documentation. They provide 100% SLA. The reason why they make this 100% SLA is basically this is going to be the entry point to every workload, right? If you have a website, how will people reach to your website? They are going to type www.myapp.com if that is your website. So this is going to be your entry point. So whether your backend system is down or not, that's going to be secondary. First of all, when they type this, it should show up, it should get resolved to an IP address, and then it should send a request. So that's the main part of it. So that's the reason the entry point itself should not be blocked. Keeping that in point, every cloud provider, at least AWS and GCP, I'm not sure about Azure. So these two cloud provider make sure their DNS service offering is going to be with 100% SLA. And updating your DNS records is very, very important. Sometimes you may have to change the DNS record. Maybe if it's, say, for example, on-prem and GCP. On-prem is having some production system and GCP is having a DR system, and on-prem has gone down due to some issues. Now we want to switch to your GCP, which is your DR system. You need to change some records, A records. Usually there are n number of records available in your DNS. If you want to change your record, there should be a provision for you to change it. So Google provides you different ways. You can do programmatically, you can use using console, you can use using REST APIs. So, and the advantage of DNS is it's going to cache your contents also. So it's going to find, Google has lots of point of presence. It's going to find out the closest one and it's going to serve you from there. So a combination of a global load balancer with a cloud DNS is going to be a good combination to serve your content very easily. So that's going to be a good combination. So it's only one slide on DNS. And when it comes to DNS in GCP, you get two flavors. One is internal DNS. The other one is an external DNS. So two options you get. So external DNS demo, we will do it later. I'll show you an internal DNS demo or a private DNS demo now. External, we'll see it maybe later. The next part is on CDN. So before I go to, or maybe, okay, we'll do the demo together. So I'll make sure I'll do the demo on private DNS together. So DNS basically resolving your domain to an IP address. That's it, simple. Now, next important concept, once we finish this concept, we'll do a demo comprehensively, because just doing silos demos may not make sense. So I thought, let me do it as a comprehensive demo. So the next important concept which we are going to learn in the networking is cloud CDN, content delivery network. You would have seen, if you have used any e-commerce website, very much sure that you would have definitely used CDN, content delivery network. The reason is you may be sitting in one place of the world, the content may be hosted in somewhere, but it's going to serve with the very, very lowest latency, because the content is cached in one of the point of presence. And the service providers, ISP, also have a great role to play when they cache the content. So the popular CDN providers are like your Akamai, all those things. So they are really good at it. And comparing Akamai with Google CDN may not be a good choice, because that's a dedicated offering. And what GCP provides is one of the options. So instead of just going with Akamai directly, if your requirement is to just cache few of the content, static contents, and serve the user with the lowest latency, you can use this product. So you can use this product. How this basically works, it works in conjunction with your load balancer. And what is the setup to do it? Very, very simple. When you set up the load balancer, you set up a checkbox. There's a small checkbox, enable CDN. And CDN has to work only with a load balancer. It cannot work independently. So it has to be working with a load balancer, basically HTTPS load balancer. So end user sends a request. It first hits actually cloud DNS. The IP, the domain gets resolved. You get an IP address that is nothing but your global load balancer. From the load balancer, the request is going to go. Then if it is going to go to some static content, it's going to be served from your CDN, content delivery network, and get it delivered. So why CDN is going to be important? Let me just tell you by doing a small demonstration or explanation. I'll do a demo later. Network regions and zones. Okay, 25 region coming up. Good. At the end, they made it up. Now, if you see this one, CDN point of presence. So the good amount of CDN point of presence. So for example, let's take a simple example. I have a storage bucket. Okay, I have a storage bucket in so I have a storage bucket in Singapore. So I have a bucket in SG. And I made that, and this, what is it bucket containing? It is having some public some images which is made publicly accessible, images, videos, all those things. It can work with HTTP and HTTPS both, Kumar. It can work with both the options. So both the options it can work. So uh, the content is there. Assume the content is there. Now I'm sitting in Bangalore. Bangalore should be somewhere close here, if I'm not wrong. So sitting in Bangalore, I wanted to access this object, publicly available object. So what I will do is I will send a request using a URL. So when I send a request, first it is going to check in Chennai. This is Chennai, this is Mumbai, this is Delhi. So DMC for Chennai. So first, when the request goes, right, it is going to check whether in Chennai CDN point of presence, do you have it or not? If it is not there, what it's going to do is it's going to hit the backend. What is the backend in this case? Basically a storage bucket. So from the backend, it's going to fill the cache. It's going to fill the cache. So this is going to fill the cache. Fill it. Once you fill it, the request is going to be served to me who is sitting in Bangalore. Now, the next time a user in Hyderabad, assume, wants to access the same thing, same request goes to first check in Chennai, and they see in Chennai the cache is already there. Instead of me hitting the back end, it's going to serve the request from your Chennai CDN point of presence. So it's going to serve it from there. So that is how CDN works basically. So this diagram is going to be good example. So there are two concepts. The example which I mentioned, I sitting in Bangalore try to access it. So when I try to access it first, it sees nothing is there in the cache. It's going to hit the backend. It could be a virtual machine, it could be a storage bucket, it could be anything. So usually virtual machines and storage are the preferred options, or Kubernetes cluster. It's going to see nothing is there. It's going to hit, get the response, fill the cache, then send the response. Second user sends a request, sees the data is already in the cache, CDN point of presence. It's going to serve it from the cache instead of hitting the backend system. So this way you will get low latency. You'll get very low latency. So that's the whole part of your CDN. So for the first user, it's a cache miss. For the second user, it's a cache hit. And you are going to also pay some cost for filling this cache, which is going to be called as cache fill. So if it is not there, it has to be filled, right? So the cache is going to be filled, and cache egress. So the cache egress, meaning from the cache, the outgoing traffic to the user is going to be called as cache egress. So based on this only, the pricing of your CDN goes. CDN goes. So that's your CDN, folks. So to basically serve any request with the lowest latency, you use this, and how the cache gets filled, all those things. If it is not there, it's going to be filled, and you can retain it for a long time, or you want to invalidate it, that is also possible. There are multiple options available. So say for example, if it's a website is having a logo, and you change the logo, now you want to invalidate the cache so that everybody, when they see it, they're going to see the latest image. You can see that you can invalidate the cache by a small option in CDN. So those were the concepts which I wanted to share today. Now what we will do is we will take a 10 minutes break, because it's going to be a long demo where we are going to use a combination. Now because we are now slightly mature enough to use multiple products, we are going to use multiple products, load balancer, DNS, CDN. All the concepts which we learned, we are going to put it in one single demo and make a website with HTTPS. Okay, that's what we are going to do, and everything is going to be free. You can also do this demo in your free trial account. You don't need to pay a single penny to do this, to also purchase a domain. So there are some domain providers who provide things free. Some domains like .tk, .ml, there are lots of domain service providers who provide that free. So we are going to use that itself to create a domain also. So let's take a 10 minutes break, come back. Once we come back, we jump into a demonstration with all this product. And there is one hidden product which is not mentioned here. You need to figure out what is that product during the demonstration. There's a hidden product here. So let me stop the recording.
This conference will now be recorded.
So what we'll do is a demo which covers all the concepts which we learned from the morning. So, and because this is a long demo, so I have put everything in the cheat sheet, folks. You can also refer to the cheat sheet. So the stuff here. Okay, so all the stuffs with some screenshots also I have put it. So it's going to help you out. Okay, so now what we are going to do is we are going to have a website, and let me see whether I have access to that domain. So if I go to Freenom, this is a service provider called as Freenom. They provide you domains, free domains. I have a domain registered last year itself. It is provided free of cost. So if I just open up this website, you can also open it. It is first of all HTTP, and it is not reachable. So now basically the resolution is not happening. So the name is not getting converted to a record currently because I have not attached to it. So the whole key intent of DNS, cloud DNS, is you should not have something like this. If you get a customer a page to a customer a page like this, they will not even come to your website again. So we wanted to avoid it. So the end goal which we are going to do is have a website which is going to show something like this, and the output is going to be that Apache web server page only, standard, but we wanted to show this, and we'll also see how static content can be served. This is the end goal, folks. This is the end goal. Let's see how we can do this. Okay, so let's do that. So for that, what I'll do is, for now, instead of going with MIG, we have already seen MIG demo, right? But we have never seen a demo on unmanaged instance group. So let's use this time to explore unmanaged instance group and do a demonstration. So, and we will try to use the best practice as much as possible, because we have come a long way in our networking concept. Nowhere we'll use it as a rule of thumb that we will never put 0.0.0 anywhere, even in our VPC or any other settings. Nowhere we are going to do that. Okay. So I'll go to my, first of all, I'll show the VPC. So I will use, I'll use, and there's a new feature also, folks, which got released. I don't know when, maybe with the last week only. You can bring your own external IP address. That's a new option also coming there. So that's there. So if I go to my VP firewall, let me see, is there any firewall rules? Yeah. So this is the firewall rule, which I don't want to do now. So what I'm going to do basically to SSH. So I'm going to use basically VPC Taiwan. In this example, I'm going to use that VPC. This is the VPC which I'm going to use. The CIDR range is good /24. So which is a good range. So that's good. Now the firewall rule for that VPC is this one. First and the foremost thing, I'm going to remove this and add a specific range, which is going to be our IAP for whitelist. There's a specific net block, right? We are going to use that IAP thing. To know the IP, you can go to your IAP settings. You should be able to get that. So first, trying to fix everything from the foundation perspective. Not opening. Is there any firewall rule which has that? I don't have that. I deleted it. Okay, I don't have a VM. First, have we mentioned that IP range? I am not sure whether we have mentioned it in a cheat sheet. First of all, IAP, nothing there. Okay, this is the one. So always remove this and add this as your source IP. So let's do that. Fixing my firewall rule. So this firewall rule, edit. Now source IP can be only this one. That's it. Port 22 and ICMP should be okay. Save it. From the network perspective, we had made it little secure instead of opening to 0.0. So let's wait. Yes. So that's good. Now what I will do is I'll create a virtual machine with only internal IP address, and I want to have a Apache web server installed also. So that's what I'm going to do. So create an instance. So I'm going to call it as web server. Web server. Web server, and I will choose Taiwan. Taiwan A, and N1 standard will go for it. So that's one thing. We can go with Debian 10 itself. That should be good. You want to put some specific service account. If you want, we can put basically, if you want, this may not connect to any service. Basically, it may not even connect to any service. If you think of, if you want, you can make it. The requirement is just a website. There's no need of any service account. If you want, you can do this, or you can set this to no service account. Basically a standard virtual machine, nothing else. You can do this. because from the virtual machine, we are not going to connect to any other services in GCP. So I will make it like this. So that's it, folks. And go to networking, change the network to VPC Taiwan, the one which we wanted. And the most important thing, I don't want external IP address. I don't want any external IP address, basically. This is the stuff which I'm going to do. Basically, I'll put it as, let me create with one service account, folks. Let me create a service account. Not sure it could be a requirement. Let's just do one service account and assign that service account. What role, we'll decide it later. First, let's have a service account. Sorry, I did not plan this one. Let me create one service account. I'll call this as cloud LB cloud global load balance or something like global cloud DNS CDN demo. This is the one which we are going to do. That's it. Click on done. We will not give any role to this, folks. So just the service account will create it. Any kind of roles we will decide later. So meaning, if I go to my IAM, if I go to my IAM, you will not see that service account itself. You will not see that service account itself. Because we have not given any role. So with that background, let me create a virtual machine. We are trying to tighten everything with all the knowledge which we have gained so far. So let me recreate the VM one more time. The restore button should come, so it can help us. So restore, that's a cool feature, I would say. So all the stuffs which I did comes back. Name is this, Taiwan, N1, then the boot disk is Ubuntu. I don't want this, I want this service account. Now, why I have not assigned any role? I don't know what's going to be the requirement. I will give the role later. I'll give the role later. So, but I am using a user defined service account, which is one of the best practices which we learned in our IAM class itself, or the cloud IAM class. So no need of any firewall rules. I don't want to open up any firewall rule here. What I'm going to do is click on the network. So VPC Taiwan, subnetwork Taiwan, no external IP address. Now, what I will do is I'll also make sure I go and install Apache web server, all those things in the startup script. So I'll try to have a startup script which is going to install Apache web server. apt update, apt install -y Apache 2. This is what we are going to do. Okay, so far is it clear, folks? We are trying to make it the best option which we know so far. We are using user defined service account. We are using a VPC which has not opening firewall to 0.0. Then what else we have? We don't have an external IP address. Some best principles we have already used. Is this part clear, folks? Is this part clear? Yes, no? Okay, thank you. Thank you, Kumar and Mahesh. So now let me click on create. Yes, Samantha, thank you. So because how long we will do all the default settings. Now we have come to a great maturity, so we'll try to do this. So now I have the virtual machine there. So no external IP address. So I have to SSH and check whether my Apache web server is installed or not. Okay, so that's what we are going to do. So I'm going to SSH. Now we are using IAP to connect. So now let me just do curl localhost. If my Apache web server is installed, it should show me Apache web server listens on port 80. It should show that, but it's not showing. Not sure why. Usually Apache web server gets installed in /ww. So you should see that. I don't see that itself. This is a standard location /where/ww/html. Even that does not show. If I type something like which Apache 2, not there, Apache not there. So looks like the startup script itself did not work. It did not work. Looks like if I just go to my web server, let me just check what has happened. Startup script. Is there any wrong thing in this one, folks? Do you feel anything wrong here in the startup script? It has not even worked basically. So if you want to see whether there's anything wrong here, give a check by trying it here itself. So trying it here itself, sudo apt update. It's not connecting to internet. Any reason why, folks? It's not connecting to internet. Why it's not connecting? Because it does not have an external IP address. Beautiful. But I cannot give you external IP address. I cannot give you, no, it's not because of IAP. So because it does not have an external IP address, I cannot connect to internet. But as per the policy, I cannot give you external IP address. Now, how will you get the update? How will you get the update? How will you install it? Now, this is one way. Your startup script did not work. You found out this way by just trying the script manually. The other way is, we had seen it in our MIG demo itself. You can go to your logs or the serial ports. So go to your serial port and you should be able to see it. Saying that not able to connect. You see this error, cannot fetch, because you don't have access to internet. You don't have access to internet. This console shows that very clearly. Now let me, please give me a fix for me to connect to internet and get this working, folks. And this is something which we have already done. Beautiful Mangesh, Vivek and Anil Kumar. So Cloud NAT is going to be a solution. So it's not working. I'll create a Cloud NAT, a best practice. So go to my, so if I go to network services, NAT. So Cloud NAT Taiwan, and the VPC which I want is VPC Taiwan. The region is Taiwan. I don't have a router. I'll create a router, Cloud Router Demo. I'll put it to my primary. I have only one primary range. I don't have anything. So that should be good enough. I'm going to leave everything as default. Now the Cloud NAT worked. So this was the hidden product which I did not mention, but since we had done the demo last week, so I wanted you to recollect it. So once the NAT is there, I should have exposure to the external world. I should update it. my startup script should start working. My startup script should not start working. Now, NAT is there. Now, this is a small trick, folks. So if I just SSH, if you had a startup script, it failed to work. One way for it to work is you restart it, stop and restart it. It's going to start it. The startup script is going to get executed. That is one way. The second way which you will do, so if I just show you ls/where, you don't see a www folder. That's where Apache Web Server gets, it's get installed and it creates a folder to keep the web applications there. So it is not there. It is very clear. And if you type which Apache or which Apache 2, nothing is going to be there, or which HTTPD, and you can also see it by service. So nothing is there. It's very clear. Now, if you want that startup script to execute, there's another small trick. One straightforward option is stop and start. Downtime is going to be there. But if you don't want downtime, what you can do is you can use the option of reset. If you just do this reset option, your startup script is going to get updated, folks, or it's going to get executed. So let's me do that. But the VM does not go down. Please note the VM does not go down. So you can see it, it is still there. It is still running. Resetting, let's wait for it to reset. Instance resetted. Good. Now, if I SSH, now let's see whether the folder exists. You see that folder? Folder exists. Now, if you type which Apache 2 or Apache, I have to do something. It does not show me. Or maybe this command was wrong. If I do localhost, okay, it shows me. It shows me the output. Instead of saying cannot connect, it shows it is working. It is working. Or you can use options like something like process -ef grep httpd. It should show. Is it really showing? Okay, it shows Apache Web Server is running. Or another way is you can use netstat -nlp grep 80. No, 1 minute. NLP is going to be a good. Okay, it shows Apache Web Server is listening on port 80. Good. So far, we have got our basic stuff running with a very secure way, not opening up external IP address, all good. So till here, is it clear, folks? Till here, is it good? So your concept, good. Now, I want you people to access this website. At the end, it is just Apache Web Server page, it works. That is a standard. But I wanted you to give access to that. But unfortunately, I cannot have an external IP address. Now, how will I give? I cannot give this virtual machine external IP address. Now, what is the solution for this? What is the solution for this? Is going to be our load balancer. I'm going to attach this VM to a load balancer. Then the load balancer, meaning it's going to and it's going to be a global load balancer. Definitely, it's going to have an external IP address. So that is what I'm going to do. And can we attach a individual virtual machine to a load balancer, folks? Can I attach this VM directly to a load balancer? Possible? Not possible. What is possible or what is not possible? So you cannot attach an individual VM. N number of times we have done it. So you cannot have a individual VM attached directly to a load balancer. So it has to be either a instance group, network endpoint group, serverless. There are lots of few options. So it should be an instance group, either MIG or unmanaged instance group. We already have seen a managed instance group demo, so we are not going to do it again. So what I'm going to do is, before I make it as an unmanaged instance group, I'll directly go to my load balancer and see whether I can create. I will have a load balancer. I don't have MIGs created or instance group created. I'm going to use L7 load balancer. It's going to come from internet, continue. The backend configuration is going to be my backend service. Now, when I create my backend service, instance group, network endpoint group, app serverless, these are new features which has come. Serverless for app engine, cloud functions, cloud run also you can attach load balancer these days. So instance group, you don't have anything. So there is no option for you to show or attach a individual virtual machine. It is not possible. It is very clear. So to address this, what we are going to do now is we are going to make this virtual machine into an instance group quickly. We are not going to create templates. We are not going to create base images or anything like what we did in our MIG. We are going to use something called as unmanaged instance group, where you don't need anything. Just go ahead and simply create it. So instance group, click on instance group. Create an instance group. Now you have lots of options. Sorry, not lots, 3 options only. 3 options. Sorry, folks, there was a small glitch. So I'll just repeat it one more time. So what we are going to do is we are going to create an instance group. We are going to create an instance group, and this time we are not going to create a managed instance group which supports various good features like auto healing, auto scaling, auto updating, load balancing. Rather than that, what we need is only a load balancer, only for a one virtual machine. A load balancer is what we wanted to use. So I'm going to use unmanaged instance group. So just click on this. You create a group. So I'll call this as unmanaged. Folks, unmanaged instance group. This MIG is a standard name which I've seen people using it. UMIG is not a standard acronym. People don't use it, but we are using it, okay, for only for the demonstration purpose. Batch 6. Now you can add n number of servers in a same zone. So the location which I want is in Taiwan. In Taiwan, there is no servers available. If I use this thing, I don't have it. C also, I don't. First, I have to select the network, I guess, first. Okay. So if I select, okay, in B, nothing is there. In C, nothing is there. In A, I have a server, the web server. So whenever you create unmanaged instance group, this is basically a zonal resource. It's a zonal resource. Why don't we add this in our cheat sheet? I'll just add it somewhere. Global load balancer, we did not add. Global LB, it is global. Everything else is going to be no. Then you will have regional load balancer. So which is going to be only in a region. Unmanaged instance group, it's going to be basically zonal. So added one server. That's it, folks. Click on create. First time we are creating it. Why don't we look into the command line equivalent of it? So unmanaged. Previously it was managed. Now it is unmanaged. And add the instance. Two commands. That's it. Click on create. Done. We have one instance. It is of type unmanaged. Now, if I go and create a load balancer, I should be able to access it. Let me go to my load balancer. I'm just refreshing the screen. So click on create load balancer, and all the 6 combinations which we see will be fit into this 3 combinations: HTTP, TCP, SSL, uh, uh, network load balancer, internal load balancer. All those things are, all the 6 types are going to be fit into this options here basically. So we are going to use, so if you use this one, you are using basically HTTP load balancing. If you mention it comes from internet to my VM, it is an external load balancer. If you say it is between my VMs, it is, what is this called? This is going to be an internal load balancer. So you get those 2 load balancers fulfilled here. Similarly, your TCP, UDP, SSL proxy is going to be covered here. So UDP load balance, sorry, TCP and SSL load balancers are going to be covered here. Your UDP is going to be covered here. So all the 6 combinations you can fulfill it with this 3 options here. Let me create from internet to my VM. Continue. So continue. I'll call this a name. G global load balancer DNS CDN backend service. Let's add a backend service. Now I'll call this as backend. So backend service. Backend service. I'm going to use instance group. Now you see that option. It shows. Previously it was nothing was there. Now we have an instance group. Good. Now the port which I wanted to listen is port 80. That is what the application is listening on. We are very clear. Remaining everything I'm going to leave it as default. So we have talked about these things in our MIG itself. I'm going to leave it as default. Click on done. So I have added a instance group. It is in this case unmanaged. CDN will come to this later, not now. So first we'll have a external IP address so that you people can access it. Slowly we'll come enable CDN at a later point of time. So I'm just going to leave it unchecked there. That's it. I'll go and click on create. Let's see whether it's going to get created. I need a health check. I need a health check is what it says. So we don't have one health check. Let's create a health check, because the load balancer needs to know where should I send the traffic. It should not send a traffic to an unhealthy VM. So it's going to see if it's not healthy, it's not going to send it. So for that, at least it should know how to do the health check. So now health check port 80 is what you are going to do, so that you are going to check your VM whether it's healthy or not, right? Healthy or not. So whether this port 80 is opened or not, folks, by you. In our VPC, have you opened the firewall rule? So if I put my firewall, go to my firewall rule, we are doing everything in basically, we are basically doing in VPC Taiwan. The only firewall rule which you have is this one. So if you just put 80 in your health check and do this, it's not going to work. it's not going to work. The health check is going to fail, right? For the health check to work, meaning from your load balancer to your virtual machine, port 80 should be open. One easiest way for me to do is open 0.0.0.0, and we don't want to do that. We have done the same thing in our MIG demo, because at that time we were not knowing much of networking. Now we know a good amount of concepts in networking. So if you do a quick search, there's going to be a specific block, net block, which is going to show what is the IP which you need to have for load balancer health check. What is the IP which you should open up? There's a couple of ranges. This is the one. For these, okay, 130 if I just search for. Okay, firewall rules for health check. The following creates the ingress incoming firewall rule for the following load balancer. So these load balancers for these load balancers, ours is this one, right? The source IP for the health check, including the legacy health, are these things. These are the health check probes which you need to open up. So create a firewall rule is what they mentioned. Create a firewall rule like this, where they are saying you should have a target like this, something of this sort. Source IP is this, TCP, all ports. If you want, you can open all ports, or specific ports also you can open. So if you want to follow this, let's follow this. Create a firewall rule like this and call this as exact copy paste. So create a firewall rule. This is to make sure our health check works. Good. Network, VPC Taiwan, incoming request, if I'm not wrong. Yes. Allow. Under this thing, they wanted to use a tag. Now, what would be the preference for you folks? Would you want to use, what would be the best option you want to like to use here? Best practice. Let's try to use the best practice. What do you want to use? All instances, specify tag, service account. Which one would you prefer to use? Yep, Mangesh, that's correct. Yep, Vivek. So service account is going to be the best way. Yes, Anil Kumar. So service account is going to be the best way. We had done a demo also. Now we are tightening up so much what we have learned. So the service account is in this project only. That is the one which you created. Why it is not showing? Let me just, okay, I may have to refresh the screen, folks. It may not have refreshed. That's the reason the third service account which we created is not showing. So allow network specified service account. Boom, we have it. So good that we created the service account. Source IP, follow it. What is the source IP? These are the two net blocks which you have to add. Done. Oh, sorry. That's one thing. The whole intent is to show you how vast the documentation is. We can easily follow the documentation and do demos, basically. Good. What else they are saying? They are saying allowed type TCP. You can put it as all the ports if you want, but if you are very specific, only port 80 is what I wanted to open, nothing else, you can put it little more secure. Okay, so little more secure, the command line is going to be something of this sort, where you are going to use basically your service account. Create it. Now we have fixed our firewall for basically the health check. Very precise way of doing it. We have done it. Maybe this firewall rule, if you want, we can also edit it, folks. We'll apply it to this one only, to this specific target. Target can be to the service account itself. Let's do that also. It's going to be the best solution which we are going to implement. Edit it. Why to apply to everything? To that specific service account. Very. Oh, it does not show the drop down when I edit it. So I have to get I have to go to my service account and get it. Edit mode, it does not show a drop down. No problem. You can get it here. We are tightening it like anything. So if I put a filter, VPC Taiwan, only to, it did not even apply. Strange. 1 minute, folks. Change it to service account, paste it, save it. Okay, now let me put it. Filter on my network, VPC. Oh, come on. It's not updating. What is that? What is that? Which is happening? Strange. Is it because I have a virtual machine already attached? But I should be able to change the firewall rule. Very strange, folks. In this, okay. Lots of bug in the issue. So it was not showing this drop down. So that's the reason I was getting stuck. Okay, good. Now it should work. UI glitch. It did not show me that option of project if you were watching the screen properly. So it was not showing it. Now it is applied. And folks, the exam dates, the new exam are going to start from May 1st. So May Day, it's going to be the new version. So all of us will definitely see basically the new exam pattern only. Just wanted to mention you that. So they have given an update. Last time they had mentioned in spring, right? What was the spring definition? They did not give. So the exams are going to be new pattern is, or the new updated version is going to be from 1st of May. So you people are going to see the first thing. So I have made some changes and I'm going to make some changes to the pattern of the course so that all the new stuffs are going to be covered, at least the case studies. Okay. So now we have made it very robust firewall rule, very strong, very to the best principles. We have done it. Now what I will do is go and click on create on my health check. The health check is created. Everything is good. Now let me go ahead and create it. So that's my backend service. So just to reiterate, we selected our unmanaged instance group and the health check. Because health checks is going to be doing a probe on port 80, we created a firewall rule, and the firewall rule was from specific net blocks as per the documentation. So good. Host and path rules, we are going to keep for now simple. We are going to keep it as simple for now. Later we'll change it better. We'll come and revisit this. Front end load balancer, front end configuration, front end service. Now for next few minutes I'm going to use HTTP, folks. Later I'm going to use HTTPS. Why? I'll tell you. Because I don't have a certificate. I have to generate a certificate. So, and I'll show you how for free you can generate a certificate in GCP. What are the prerequisites for that? So first let me just have a HTTP, and if you want you can reserve it or you can leave it as ephemeral. Either one is fine. Let's make it as ephemeral for now. The port is 80. Done. So finalize. So you have one unmanaged instance group and a front end service which is going to be HTTP. That's it. Click on create. So we know this load balancer is going to take around 5 minutes to provision. So let's wait for a minute. Okay, the load balancer provision, but it's not fully up there. So if I click on the advanced menu, I'll come to know the IP address. So if I click on this, it will show something like this. This is the IP address, folks. This is the IP address. It's going to take time for it to come up. For it to come up, instead of we waiting for it to come up, what we are going to do is we learned DNS, right? We'll try to apply the concept of DNS to this thing, so that we'll have a domain. We already have a domain. I have registered it, so you can just go to this website freenom.com. You should be also able to register it, or if you already have a domain, you can use it also. So it's a straightforward option of creating a domain. You should be able to do it, and you get it for 1 year. But it's not a popular domains. .com is the most popular one, right? .tk is something provided in New Zealand, so it's not that popular. So but for our demonstration purpose, this is good enough. So what I'm going to basically do is map that IP address to this using a concept called as A records. So for this, you need to have your cloud DNS configured. So let me go and configure this, because anyway, it's going to take time for the load balancer to come up. So I'm going to use that time. So what I will do is I'll go to my, till here is it clear, folks? First of all, till here is it clear? So we are just waiting for our uh, page to show. Basically, Apache web server, it works. That page is what we are expecting to see. So till here, if it's clear, I will create a domain. So network services, cloud DNS. Maybe the API is also not enabled. We may need to enable the API. First time we are coming here. So it is not there. Highly scalable global DNS network. So let me enable this. I don't have this enabled. Okay, it is created, and you can go ahead and create zones. This zone, DNS zones, and the normal zones, which you know don't mix up. Totally different terms actually. I would call these as zones are nothing but folders like that kind of a stuff. So inside zones, you create multiple records. Records are like, it's like a folder. Inside a folder, the files which you are going to have. So that is a kind of analogy which I can give, but this is not related to your zones, the GCP zones which we have learned so far. Define lets you define your namespace. You can create a public or a private zone. So first we'll create a public zone. Once we do this demonstration, I'll show you a private zone demonstration. So private, sorry, public is what I'm going to do. Now there's a pattern in which you need to usually give a zone name, the DNS zone name. Usually if your domain is, say for example, in my case the domain is this one, learnGCPwithMahesh.tk. So if this is your domain, have the zone name as hyphen separated. That's a pattern, folks. So that's a pattern. So you can give whatever you want, but I usually use a pattern like hyphen separated, so that it's very easy for me to know what is this zone used for. Easy way, right? Hyphen separated instead of dot. Okay, so that's the name, this thing you can have. Then what is your domain? So my domain is this one, learnGCPwithMahesh.tk is my domain name. And you have a feature called as DNS security. So usually, right, there are few hackers who can poison your DNS entry. So if somebody types www.myapp.com, if it was supposed to resolve to your load balancer IP, instead of that, the hackers can poison the DNS entry and redirect it to their website. To avoid that, turn on DNS security. So the DNS poisoning is not going to happen. So it's preferred to turn it on. So that's it. So let's look into the command line equivalent of it. Beta DNS create a zone. That's it. And it's a public DNS. Click on create. Now when you create it, right, you will get something called as name servers. So usually name servers are going to be, every domain providers are going to provide you minimum 4 name servers or 5 name servers. Why 4 or 5? Because basically you have continents, one for America, one for Asia, one for EMEA, one for Africa or South America, something of that sort. So you will usually have 4 or 5 name servers. This way, the resolution happens quickly in those specific continents. That's the main reason. So Google provides you 4 name servers. So one for America and South America, North and South America, one for EMEA, one for Africa, one for Asia. So these are your name servers. Now, the different ways how you play around with your name servers, the way which I learned, which I felt was very helpful, was change your name server configurations in your service provider. So if I go to my service provider, and if I click on manage domain, every service provider will have their own name servers, will have their own name servers. I'll show you their name servers. Free norm. Okay, this is already, it would be like something like this, folks. Free norm will also have a name server. So by default, it's going to be something like this. It's going to be something like this. What you can do is you can change it. You can change and add up to 5 name servers. So we have 4 name server entries. I'm going to add this. So 2, 3, 4. Those were the name servers which was mentioned here. I have used it. That's it. Click on change. I'm going to fully use my Google Cloud name servers instead of relying on some other name server from the service provider itself. So these are my name servers there. Good. This is the first activity. The second thing is, let me see whether my load balancer is up. Still not there. So soon it should be up. So I'll copy this IP address and add a record in my cloud DNS. So everything is going to be a record here. One is a name server you have added. We can add different types of records. The record which I'm going to add now is called as A record. It's a A record. So you have different types of record types. A is going to be for IPv4. 4As is for your IPv6. Since I have an IPv4 address, I'm going to use A record and time to leave, how long the content needs to be cached. So if you are A records keeps changing very, very frequently, you can make it as even 1 second. Even 1 second. If you frequently change your A records. But if you don't change it, keep it for minutes or for hours. So for us, I'll keep it as the default 5 minutes. Now mention your IPv4 address. This is my IPv4 address. So I have created a record. Add it. Maybe one more time I'll show you a record. I wanted to show you the command line equivalent of it. So I'm just going to add this one more time because this is the most important thing. So command line equivalent. So you do it like this, folks. So you create a transaction, add your entry and execute the transaction. So this is how the stuff goes. So G Cloud DNS, add your A record. Similarly, you get a REST equivalent also if you want to do programmatically, something like this. Maybe from a cloud functions or something, you can trigger this to update your A record. programmatically. So now I have added a record. So I have done a mapping. If somebody types the learn GCP with mahesh.tk, it gets resolved to this IP address. Simple mapping, right? Simple mapping. Now if somebody types www.learngcp with mahesh.tk, it should also get resolved to the same thing. So for this, you add a record called as CNAME or canonical name. So if you do that, people who type www.com, so that's going to get resolved to this. So if I type www.com www so www.learngcp-with-mahesh.com .tk, it should get resolved to learngcp-with-mahesh.tk. Now learngcp-with-mahesh.tk gets resolved to the global external load balancer IP address. So you see, and once it hits, it's going to route the traffic to your instance group. So that's the mapping. So looking at the command line equivalent, again, it's going to be same. The type is, instead of a record, it's going to be a CNAME, canonical name. So if you don't want www, this kind of a resolution, you don't need to add it. This is an optional one, but for search engine optimization, all those things, having www.com is going to be a good choice. www, the World Wide Web, is going to be a good choice. Two types of records we have added. And similarly, you can add n number of other types of records. For example, MX is for sending mails, text records. Sometimes Google is going to ask for verification of a domain. So at that time, you may add text records, which is not going to impact. If you have an IPv6, you can have the 4 A's type of record. So different types of records are available. So I have added these things. Now we should be all good to see things working. So first of all, the DNS part, we have done it. So configured our DNS, updated our name server, mapped our A record, and we created a canonical name also. We are all good. Now things, if everything is working fine, by just opening learn GCP with mahesh.tk, it should show Apache web server pages working. The things are all fine. So first of all, let me see whether load balancer is working. Load balancer itself is not working. So we need to see why it is not working. We have tightened it so much, so don't know where it has broken. So load balancer, first this should happen, the resolution should happen. So otherwise it's not going to work. So let me just see what is the issue. If I try it here, okay, the DNS resolution has happened. So if you now try it, folks, if you try this, DNS is working fine. It is resolving to our IP address, but it is not, the load balancer is not able to send request to our MIG, so our unmanaged instance group. So if you go to your DNS also, put this, it should show it should show my, yeah, you see this? What is this IP address, folks? This is nothing but our load balancer's IP address. So the resolution is happening properly. So it's getting resolved, but I have some issue with my load balancer. So let's look into the logs to see what is the issue. So it may help us to find out what is the issue. I'm also not sure what is the issue. Mostly it's a firewall issue is what I feel. So let's check it out. So I will go, we have not looked into logs heavily, but for now I'll just go see the logs part. Is there an option I can see it here? Forwarding rules. There's no option for me to see. I'll look into the logs. Logs to see what is the issue, why it is not working. Let me just see it. If it can give us some thoughts, ideas. Something, it is showing some error. Okay, this is not done. So let me put a filter on load balancer. Let me see whether health check is working. Mm, 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 mm. Health check, good. I'll show you how to explore that logging more in our on a different class. Uh, mm, what else? You have to send request from load balancer. It goes. Health check does. Should I open up port 80? Not required. Not required. Let me just see one more time, folks. Okay. Somewhere, if I can see the logs, it's going to be helpful. Which part of the log to see? Let me know thoughts, your folks. Okay, it's already showing something. It's unhealthy. Okay. Okay. It is showing. It is giving that message at least. That helps us. Uh, it is saying it is unhealthy, meaning my firewall rule is not working. My firewall rule is not working is the key indication. Health check. Uh, monitoring health check. Let me. It is saying the health check is unhealthy. Advanced menu. IAP, we have not even come to that. We have not even come to IAP. I guess let's look at the firewall rule, folks. Was there any mistake? Port target. Target is this one. Is that is good. The source IPs. Hope it is properly captured. Proper. Proper. This thing is good. So from the load balancer, it's going to hit port 80. Port 80. VMs with that is going to show that it is healthy. What else? What else we should have? Everything is good. Let's turn on logging. So if I see here, look into this. Here the logging is disabled. If we enable logging, maybe something can come basically helpful. Let me edit the backend and see is there anywhere I can enable the logging under advanced settings. Maybe more logs can be the logging can be enabled. Yeah, enable the logging so that we get some idea what is happening. We're not getting any idea there. So sample rate must be updated. What else do you feel as in DAO this thing? So from here to here looks fine, but not sure what is the thing which went wrong. Let's just check it. Let's wait for the logs to start coming up. then we will see an idea. Is there anything, something which was messed up? This is real debugging, folks. So I cannot recollect what is something which has gone wrong, but we made it very strong, strict. So if I can see load balance. So jump to now. Let's see now. Jump to now will show the current logs, which is showing. Okay, something it is showing now. Let's see this one. Failed to pick up the backend. You see this? It's not able to pick the backend, the right backend. So the logging helped us a little bit. So at least it is showing failed to pick up the backend. Then this is the backend warning. Okay, let's see. Backend, it's not able to pick it up. This one, something wrong with our backend configuration. Let's just check it out. Nothing here. Here. Not getting what is the issue. Mostly it is to do with the firewall. Health check. This firewall has no impact. It's only this health check. For a minute, I'm just going to open this. See, this is the thing. At least pinpoint that this is because of this firewall only it is having the issue or not. I'll just edit this. I'm just going to open it up, folks, for a minute. Service account, beautiful. Yeah, that could be that service account connecting. You mean to say that could be the issue? Okay, 1 minute. That could be possible. Service account having what role is an important thing. So, okay, first what I will do is a good one. So first for a minute, I'll just apply to this, folks. All instances in the network. Okay. If I put all instances in the network, this firewall is going to apply to everything, every instance. We have only one instance. If this works, then it's going to be something to do with the service account is what I will see. Then we'll figure it out. A specific role which we have to give to the service account. So service account, what is that? We'll figure it out. If this does not work, then something else. But that's a good point, Mangesh. So I have changed the firewall rule. VPC. So I have made it to apply to all. Now let me see whether it can work. Okay, Mangesh was correct. So it's something to do with my service account stuff. We need to figure it out. What is the right role which you have to give? So let's verify that. So it worked. It worked, and even your this thing, learn GCP with Mahesh.tk should work, right? So thanks, Mangesh. That was really awesome, I would say. Now we have to figure it out. what's the role which I have to give. So what I will do is this part. So for now, what service role should you give? Load balancer, what role to give? Any thoughts, folks? I'm totally blank. I'm totally blank. What to give? Now, if I see the load balancer, is it healthy? Yeah, it is healthy now. What role would you think, folks? What role? We have not given even a single role to this. Uh, should it be able to at least read the virtual machine? Something like that. That role would be enough. Let's just give something related to virtual machine role, compute engine admin, something of that sort, and see whether it works. Okay, see whether it works. So before that, I'm going to edit this virtual firewall rule, edit it, change back to service account, change it back. So network, what is that? VPC, network VPC. So it is back to the beginning stage which we created. Now let me see whether it works. It will not work. So we have set it back to a stage where we were getting error. Now what I will do is I'll go to my IAM, give that service account a specific role. I'll try giving something related to compute engine because this is going to touch the virtual machine. So I'll give that service account. To be very frank, I'm not sure what is the service account which is going to be helpful, but since it's going to use virtual machines, I'm just going to give something like virtual machine compute admin. I'll give it and see what's going to happen. And that's going to also have some networking roles. So maybe we can fine tune it once we come back. Let's give this role. Yes, it is there. Now refresh it. No, it does not work. So it's nothing to do with compute admin. Compute admin. Anything else, folks? I'm not able to connect it. That's the reason. If we connect, we know where what needs to be given. That specific role can be easily given. So, but compute admin did not work. For a minute, I'll just make it as an editor role. For a minute only, just to check, because not getting what is happening. And this is reality. This is what you will do it also in your real project. Something not working, you will give a privilege, higher privilege, and try it out. Now I have given it as editor role. Let me see whether anything is going to work. This is little fishy, folks. Or should I always go with this option? A load balancer. We are very sure that the firewall is creating the problem. That too, if we use this. So if I use point to explore, this is a good point to explore. So what I will do now is any thoughts, folks, before we do anything? The simplest thing which I can do is follow this way. Specify target, use this target and do it. That's going to work. But anything else which you can think of, like what Mangesh thinks, so was a good one. The service account was the one which was creating issue, or the firewall rule using service account was the one which was creating. Any thoughts, folks? Even though we don't do the demo as per today's part, it's okay. But wanted you to think what could be the possible things which you can do. We have a solution. Either apply to all tags to all the instances in the network, or something go with this option. Create a target tag called as allow health checks and do it. We can do it. But with service account, do you think something can be done? I'm not getting any clue. What could be the possible option? So this firewall rule, we gave editor on access itself. What else you can expect? Can we give a network related role? We gave editor itself, right? Editor is the next to owner, right? So we have given that. We can also give owner access and give, but I don't think so it's going to work. We can give it. We gave the role editor. It took a good amount of time to propagate also. It's not working. It's not working. Uh, um, not sure what is the stuff, or is, if we just go with this as per the requirement, it has to be always a target only, not this thing. Not very sure. Let me also think. So for now, I'll go with this option, because opening the firewall target as all instances, at least we'll make it little better. Service account did not work, so I'm going to remove this service account. I don't need this. This role is not required for now. Now I'll go to my service account. Do we need, we also need to remove VM? No, we don't need to remove any VM. So I'll show you how do I play around with this. So I'll specify a target as per the text which was mentioned. That's something. No, from the no, you don't need to remove the service account from the VM. So service account will be there, but it has no roles currently. So what I will do, I'll follow what is mentioned here. Allow health check as a target. Okay. Now, if I refresh it, it does not work. Any reason why it does not work? If I make it as all network, it works. If I give it the service account, it does not work. But if I follow this one, it still does not work. Any reason why, folks? What are we making wrong here? What's that which is wrong? So maybe I can help you out. Beautiful, Vivek. That's the most important thing. So yes, Mangesh. So for that VM, the tag is missing. For that VM, the tag is missing, which is very clearly mentioned in this firewall rule. So it is saying it is not applied to any VM. So the tag is missing. So go back to your virtual machine. And if I put a tag, network tag, so there's nothing, there's no tag. So edit the virtual machine, add this tag. Good. Now add it. The moment the tag starts working, if I go here, boom, it works. So at least as per this thing, it works. It is not working with service account. So need to figure it out. You can also explore it. I'll also explore it. Once I get an answer, I'll let you know, folks. Okay, so we have finished what part of the demo? We have a load balancer. We have a DNS that is working. Is it resolving for everybody, folks? If you type learn GCP with Mahesh.tk, is it really working for you? Yes, right? And let's verify whether it is really ours, or I'm doing some cooking here, or I'm uh, is it a fake thing? I just wanted to verify it. What I will do is, in front of you only, I'll try to edit the content. We'll try to edit the content and see what is going to happen. The moment I edit the website content, you should be able to see the content changing. Okay. So why it's taking longer time? 1 minute. I'll go back to my SSH. tag is there. Hope the SSH works. Just to verify that whether it's really our website or somebody else's website. So we have done the DNS resolution. We see that it is working, but just for our confirmation, we will do some more confirmation by like some changes and verify whether the changes are reflecting. If the changes are reflecting, definitely it's going to be something which is going to work. This long time, if it is taking, something is wrong. Anything blocking? IAP is there. Okay, let me give a retry. If I just refresh this. Oh, all port. This is TCP port. Okay, this is good. Don't know why it is taking longer time. Let's check it out. Taking long time. And I need to log in. There's a specific task which we need to do. Why it's not logging? Again, it's firewall issue. But looking at the firewalls, what could be the issue? We have already opened up 22. Should be okay. Real problems, folks. Real problems. I think the service account was removed. No. Okay. What I did was service account role was removed, Mangesh. So I did not give it any role. You see, don't role. It does not have any role. But the service account is going to be there. I did not delete the service account. The role to the service account was removed. So if I just go here, you see this? I'm in service account. Service account, the service account is there. It does not have a role. Okay, role, you can see it in your IAM. It does not have a role. Not sure what is the issue. What's the issue? Basically, it's firewall. Which firewall rule is it to SSH? So this one, this is all good, looks good. It was good, right? It was working. We tried it. We also tried it. It worked. So what could be the issue? Let me see whether this is applied. Oh, okay. What is happening here, folks? Okay, got the answer. So it's not going to work. So if you just click on this firewall rule, the easiest trick is when you click on any firewall rules, you will find for how many VMs that firewall rule is applied. This is working. For this one, no VMs are there. So this firewall rule is not getting applied. What could be the issue? What could be the issue? If I just go to my compute engine, just wanted to show whether that service account, the VM has that service account or not. Let me just show you. Something strange. Something strange, folks. I don't see the service account present itself. Oh, very strange. Service account exists, but it is not showing. I remember we put the service account, right? It does not have a service account itself. Very strange. Let me edit it. Very strange. The service account itself is not applied. It does not have a service account. How can this happen? Okay, folks, let me stop the VM and attach that service account. The service account exists. Very strange. I'll assign a service account once again. I don't know what happened. I feel it is a possible bug if I'm not wrong. So edit the virtual machine. No service account. It became no service account. I don't know how. By deleting it, it did. I was thinking the service account removed from the VM. So how can you remove a service account if the VM is running? That was the key part. That was a key part. I'll also look into the recording one more time. I'll try to recreate it, folks. As a quick fix, I've stopped the VM. I've attached the service account. Just removing the role, will it remove? That was very weird. That's a very weird one. And how can you do that with the VM running? That is also very weird. Hope folks you are seeing the stuff. So it's not the beautiful things which we are seeing. We are seeing the other side of GCP where you'll see the issues. So which is going to help you out in real this thing. So now if I refresh this page, okay, the firewall rule is applied. Very weird, folks. So now SSH should work. And this is how you will do in your real work, basically. At least in the dev environment till you get everything up and running properly. And all this design principles is going to help you out. Now things is there. So now to verify whether I'm really the one which is coming is my page only, what I'll do is I'll become a sudo user, root user. I'll go to /where www.html. So the index.html, what you see behind this terminal is the actual page. Now I'll do this, edit this file. I'll edit this file where you will see that it works, that banner, right? I'm going to change it. Debian, it works. Okay, this is the text, folks. It works for batch 6 GCP learners. Yes, saved it. Now I have saved it. Please refresh it and see whether it reflects for you folks. Is it reflecting? It reflects for me. So it's 200% sure what we are accessing is the actual virtual machine, which is served. Now the virtual machine without an external IP address, we leverage in, the load balancer. We are seeing things working fine. We also have a DNS added. Now let's go ahead and try to create a HTTPS and HTTPS also. Before that, let me try www. Learn GCP with Mahesh. Now it gets resolved. It gets changed to learn GCP with Mahesh.com. So it is working. So everything is working. Now I'm going to make it as HTTPS. So let's see how we can do that part. So for that, I'll go to my load balancer one more time. So load balancer, edit the load balancer. Now what I will do is, its best practice is the IP address which you have got, the external IP address. This is your global external IP address. Make it as static, folks. It's a preferred one. That's going to be good. So make it as static. My website, so that if you by mistake delete your load balancer, the IP address is still going to be there. Your A record is going to be still there. So things will work even if you create a new load balancer with the same IP address. So making it static is good. Now, what I will do is in my load balancer, I will create one more front end, folks. What is that front end? One more front end. It's going to be HTTPS. So I'm going to use a protocol HTTPS. Now I'm not going to create a new front end. I'm going to use the same IP address. Does not show itself. 1 minute, folks. Let me just refresh it. Edit it. Add a new front end. So HTTPS. Now I use the same IP, folks, the static IP which you used. I'm going to use the same thing. Now this is going to be port 443. Port 443. Now I don't have a certificate. I don't have a certificate. So you can add a new certificate if you want. This is going to be called, there are two types of certificate. If you already have something from a service provider, upload it. If you don't have it, you use a feature called as Google Managed Certificate. So Google Managed Certificate. So with that, what you will do is it's going to be totally free of cost. Google is going to provide it free of cost. The only prerequisite is you need to have a valid domain, so which Google can test it out. So I have a valid domain. It is also resolving. So I'm just going to put batch 6 SSL certificate. So the domain is learn GCP with mahesh.tk. So I'll also add www.learngcp with mahesh.tk. And the reason why I first created HTTP and then creating HTTPS is for only this purpose. So now it's going to verify whether a domain exists, meaning it's going to send a request. It's going to get 200 OK response. Then it's going to decide, yes, this domain exists. Let me create a certificate. That is what it's going to do. So that's the reason I first created HTTP. It is accessible. Once it is accessible, I can create a certificate and now make it as a HTTPS, and I can do that. So that's it, folks. So this is going to create a managed Google managed certificate, and this certificate is valid for 3 months, and it's going to auto renew. It's going to auto renew, and this certificate is from Let's Encrypt, the open source community there. So if you want something much better, you can use something else from a service provider. But for demonstration purpose, this should be good enough. Having an HTTPS website. Done. Now SSL certificate is going to be created soon. Click on done. So now I have two front end, one HTTP, the other one is HTTPS. So review, the certificate is still provisioning for me. It should take maximum 30 minutes for the certificate to provision. So let's wait for that. And let me click on create. The next action is you should be able to see a HTTPS URL, meaning if I just type https:// now it will not even work. It will not even work because it is HTTPS. Soon it will start working once my certificate is provisioned. So the certificate, if you see, it is still provisioning. Behind the scene, it's going to verify things, all those things. It's only 1 minute ago. In next 15 minutes maximum, it should have the things up and running, folks. Okay. So by the time this comes up, 15 minutes, we'll not sit idle. What we will do is we'll do the last piece of the demo, which is going to be a CDN. CDN. How do you add a cloud CDN for it? So for this, what I'm going to do basically is I'll create basically I'll first edit this file. Or first let me create a folder. Make directory called as dynamic Dynamic is the folder. So some dynamic content I'm going to do. I'm going to copy this index.html to dynamic folder. Basically, I'm going to have the same output. So what I will do is I will edit some content here. I wanted to show you cloud CDN and host and path rules together. So index.html, it works. Now it works for batch 6. I'm going to remove this. This is a dynamic page showing host and path rules. Path rules working in action. So this is a new content. So that way you will come to know whether it is the new content or the other content served. So I have this. This is the first step. Now, second step, what I'm going to do is I'll create a bucket. I'll create a bucket to host some static content. So I'll create a bucket. So I'll call this something like CDN. For the minute, I'm just going to use project ID, folks. Highly don't do this, but in the interest of time, I'm just going to do this. Or why don't I do that? Okay, let me just, what's this thing? GUID online generator. Let's follow the best practice as much as possible. Okay, copy this. Folks, I may need 10 more minutes. Sorry. Static content. If you want to make it as multi-regional, make it. It's always good if you are hosting some public content. Because it is in Taiwan, I'm going to use it in Asia. That's it, folks. That's it. What I'll do is I'll create a folder called as static. All the steps are in the cheat sheet. Now inside this folder, what I will do is I'll upload couple of images. Let me get some couple of images quickly. Google GCPR GCP images. I don't know what is this website. Any website is okay. I just need an image. Okay, this is the image, folks. Doesn't look good. Let me take a better image. Okay, this looks good. So I'll call this as I guess these days you get a new version, JPEG. Okay, it is downloaded. I can see the image editing. Okay, I see the image in my paint. It's a small image. That's okay. Now what I'll do is I'll rename it as GCP. Upload this to my storage bucket. And we have seen in our storage class, you can, yeah, we are going to cache it. That's the whole purpose, Kumar. We are going to do it. So I'm going to make this object as public. Okay, they have changed the setup. So I'll make this bucket as public. all users. So to make it public, storage object viewer is good enough. Now I made it as public. If I go to my object, I get a URL. I'll paste it in the chat. You can also see it. Now this is good. This is good. This is a standard feature which a storage bucket gives. But the problem is, if you look into the URL, a smart person like us will come out that this is stored in Google Cloud Storage and the bucket name is this one. You're disclosing the bucket name, which is not a good practice. And whenever you keep an object in Google Cloud Storage, make it public, it is going to be cached only for 1 hour. After another 1 hour, after an hour over, if you hit again, it's going to hit the backend system. So caching is going to happen only for 1 hour. But if you want a longer caching and you don't want to mention the URL, all those, the bucket name, all those things in the URL, having a DNS is going to be a good choice. That is what we are going to provision now. So what we will do now is we'll go back to our load balancer. So let me see whether the certificate is provisioned or not. Awesome, the certificate is provisioned. So that was really fast, folks. How long? Can I see the time? So it was very fast. Now, if you type HTTPS, should work. Beautiful. Is it working for you people? HTTPS. We have a website with HTTPS. Let me know whether it is working for you also. I guess both are working for me. Is it working for you people? Good. So it has propagated across all the parts of the world. That's really good. Now we are almost there. I just need 10 more minutes of your time to show the CDN part of it, and then we'll stop the demonstration. So the last part which I wanted to show is CDN, how caching really works. Okay. So for that, we'll go back to our load balancer, edit it. We will add a new low backend. So all these days we always added a backend service. Let's add a backend bucket. Backend bucket. Call this as backend bucket. Browse. You have this one. This is our bucket. Now I'm going to enable CDN, folks. Now I'm going to enable CDN. Done. Now I can mention how long it should leave, how for duration. I have full control. I have full control to my CDN part. Just a small checkbox. That's it. Cache static contents recommended. So that's it. So if you see, the content which we are caching is an image, images, JavaScript contents, all those things. Good. Just click on create. That's it. I have a backend service. I have a backend bucket. Now, because I have backend bucket and a service and a backend service, I can definitely do some. I have two services, folks, a storage bucket and a virtual machine. Now I can use my host and path rules, which is going to be something like this in the cheat sheet I have mentioned. So this is what we are doing actually. So everything is mentioned in the cheat sheet. Now you add 3 host and path rules. One, if somebody just types www.learnGCPwithmahesh.tk, it's going to directly go to one service. If they put /dynamic, it's going to go to the same service, but it's going to serve a different page. Then if you put static, it's going to serve from a static content. So this is what is going to be done. So let's try to do this mapping. So all these times we always used a standard one. Let's use now a better one. So www.learngcpwithmahesh.tk. I'm going to call this as star. If it is star, let it go to my, or what is that which I mentioned? Okay, I can mention it to go to my backend service. I cannot delete this. Okay. Okay. Anyway, it is going to go. Let's keep this. If somebody types learn GCP also, it should go. Either one of them, it should. If you just type it, it's going to go to the backend service. Now, if there is something like this /dynamic in the URL, if there's a word called as dynamic followed by whatever it is again going to hit my backend service only, which is my virtual machine. Similarly, I'll put it for this also. The last one, where I'm going to put it as /static. If I do this, what's going to happen is I'm going to say route it to my bucket. So which is going to go to my storage bucket. So that's what I'm doing. So 3 hosts. So if you ask me, this is not at all required, because if any unmatched is there, it's going to go to that only. But just for the clarity purpose, I have given you this. So 3 host and path rules. So is this part clear, folks? Why we are doing this? So based on the context, the URL domain / what is the URL, you are going to see basically change your backends. You're going to change your backend. So that's what we are doing here. Let me click on review. So I see good things. Let me update it. I just need to refresh it so that it reflects the changes. Okay, I see my host and path rules added, folks. Host and path rules added. So it should take few minutes for it to reflect. It's not going to be so immediate. Let's just give a minute. So I'll check whether it is going to work or not. HTTPS, you can also give a try /static/ what was the name of the image? Currently it shows like this. You can also see it. It's going to show something like this. Or if I do dynamic, the changes are not still reflecting. It's going to take a time for the load balancer to get updated. Dynamic index.html. This is also not there. This is also not there. Dynamic. Sorry. There was a typo. Okay, this is working. This is working, folks. This is working. The route is working there. This part is the one which is not working. Static. Let's just wait for a few minutes. It should start working. So once it starts working, we'll definitely see how the caching is happening. First time you hit, it's going to be from the server. Going forward, it's going to hit get the details from the cache. So we just need to wait for a minute or so for it to. Awesome, it is working. Is it working for you folks? Both are working. Awesome. So both are working. So this is the one where the content is actually served from a bucket. Now nobody can know whether it's hosted in Google Cloud Storage or in AWS or Azure. Nobody knows that because the content is in cache. Now what I'm going to do is the last piece. where I'm going to launch a Cloud Shell and hit continuously this website, this one. So continuously I'm going to hit it. So to show that it is going to come from cache. So I'm going to use a small script which is there in the cheat sheet itself. This script, folks. So this is the script which I'm going to use. Four times I'm going to do a, I don't know why this is so big. So what is this script going to do? 3 times or maybe 10 times. 10 times I'm going to run a loop where I'm going to access a website, which is this one. And let's see what is going to show in the logs. Logs. Okay, that's the one. So I'm going to launch my Cloud Shell. Okay, some mistake. I'll put it in one line, folks. Instead of fire, it is GCP. There's the stuff, right? GCP PNG. Sorry, JPEG. 3 times. Now, if I run it 10 times, now what is that you see in the output, folks? What do you see in the, this is the time it took basically to download this object. So this is basically the time it took, 200 milliseconds. Then it took only 8 milliseconds. Then it is consistently 10 milliseconds or 11 milliseconds. So this is a clear indication the data is coming from cache. It's not hitting the backend very frequently. I can also verify this by looking into the log. I'll just show you this and then we'll stop it for the day. So if I just go to my logs, which we'll explore more as we go. So if I just refresh my logs, so I already see lots of log information here. So I see the logs. If I open up one of the logs, so I guess people are hitting it. So if I just open up any one of the latest log, folks, the latest logs, any one of them, expand it, you see response is from cache. The response is from cache. It is not from this thing. The response is from cache. Now I'll show you one of the response in the beginning, where it was hitting for this one. It is not found, page not found or something like this. If it is of that sort, I guess the first one would be this one. You see this, folks? GCP.png JPEG. You see response sent from the backend, sent by the backend. All other response, if you see, it's going to be coming from the cache, coming from the cache. And this SIN indicates basically it is from Singapore. That is what it indicates basically. Some request is coming from Singapore, and if I see, most of them are showing as Singapore. It's going to basically show from which point of presence it is coming from. So that's something on the CDN part, folks. So complete demo where we saw all 3 products together. Okay, so let me just stop it here. Thank you for giving me 10 more minutes. My sincere apologies that service account took the time. Otherwise, we could have finished it well in time. So we'll stop it here, folks. Tomorrow, when we resume back, we will see something called as how we can secure this load balancer with a concept called as Cloud Armor. Mostly we should finish our networking next tomorrow. Okay, let me stop it here. If you have any questions, happy to answer. Otherwise, we'll stop it for the day. Folks who have a hard stop can log off. No more further lectures, folks. Thanks for giving 10 minutes extra for me. Any questions, folks, on the entire demo which we did or anything which we did today? Thank you, Aman.
Uh, Mahesh, I couldn't
Yeah,
follow
Kumar.
that static and dynamic which you mentioned. What exactly is it?
So what I did exactly was basically to show I have some dynamic content, some dynamic pages. So I put it in a compute. It was, if I just go here. So I had some dynamic content served from my virtual machines. So virtual machine, you'll have a code which is going to run and go do it, right? If it's a static content, it's going to be from a storage bucket. So I wanted to show I can manage between dynamic content and static content. For example, if you go to any website, you will have some secure page to log in. So that is going to be from a code, right? So that has to be served from a virtual machine. So that's the reason I gave a name like dynamic, which went to your virtual machine and serve the request. And if it's some static contents which I have, so in my URL, if you see, if I just copy it, so in my URL, if there is the portion of the URL contains static, all the request is going to be sent to my storage bucket. That is the rule which I built. So that way I can have multiple services like this, but one load balancer. One load balancer based on the URL is going to send it to different services. That was the one which I showed, Kumar. Is that clear or not clear still? Kumar?
Yeah, yes, Mahesh. Yeah, got you.
Any other questions, folks? Okay, so if there's no questions, I'll stop it for the day. We'll see you tomorrow with Cloud Armor concepts. All right, folks. Thank you. Bye.